All right, guys, let's get rolling. We'll hopefully right now Desiree could get this audio going. So today we're going to be going over A6 Electrical. I called it a boot camp, and the reason why is we're going to cover 4 weeks, so actually 5 weeks of electrical in 2.5 hours. Okay, so we're gonna speed through it. Um, at the same time, if you guys have any questions, make sure you guys let us know. This is being recorded, so whoever is online, if you guys have any questions, put them in the comments, and then we'll get to you guys. Um, Jose, you want to monitor on your phone on YouTube, and then if there's a question, then just let me know. So this class I put together based off of the ASE A6 outline. So this is going to cover everything that's going to be on the actual test. So if you guys are going to be taking your ASE exam, we're going to cover pretty much everything that's going to be on there. Obviously, what I'm going to go over is not going to be answers, okay, because I don't get access to answers. But if you guys understand everything we're going to hit today, you guys can pass this test. Okay, this test is not difficult. One thing, I know there's a lot of people that talk bad about ASC. There's good, there's bad. In my opinion, ASC is a good way for us as technicians to know where we're at. Okay. Other than that, I don't know about you guys, but I know a lot of techs who are, hey, I know how to do everything. But the moment you give them an electrical problem, they're like a chicken without a head, just running in circles, don't know shit, but claim to know everything. Okay. This is how you can really tell. On the other hand, I've seen some technicians who pass this test but have absolutely no clue how to fix a car. So there's both sides of the spectrum. Okay, and this goes for anything. I've seen medical doctors who have a PhD or multiple PhDs and are physicians somewhere in the US, Mexico, or another country, but they can't cure you from anything, right? So it's the same thing. They're everywhere. The problem is there's really no way to weed them out. Okay, the only thing we could do is this is a way that you guys can see where you're at in your knowledge base of automotive electrical. And if you guys take this test and don't pass it, it's okay. But now you know where you're weakened. Okay. And us as techs, we need to know where we're weakened. And I'll tell you where my weaknesses are. And you need to know what your weaknesses are because we don't know it all. And you shouldn't know it all because you can't know it all. Does that make sense? Okay. So, again, if there's any questions, go ahead and let me know and then we'll cover them together. So first things first, I always talk about this. This is near and dear to me. Specialty training. So one of the things in automotive is we need to be able to understand what is our specialty, right? If you don't know what your specialty is, you're going to be wasting a lot of time and money and effort trying to learn something that's probably not your specialty. Does that make sense? For me, my specialties are electrical, engine performance, and emissions. Can I do everything else? Maybe. But if you give me a car that doesn't cool for AC, that's going to be very expensive for me to diagnose it. Does that make sense? But if you give me an electrical problem, I'll figure that out relatively quickly, which is going to be a lot cheaper, right? But the average tech can't do electrical because they claim it's too difficult, right? So it goes hand in hand. And the reason why I talk about specialty training is if you guys understand and know what your specialties are, can you charge more for that? Okay. And if you're not sure, think about it this way. The last time you went to the doctor, if they sent you to a specialist, who charged more? Your standard doctor or a specialist? Specialist. So if you can become a specialist in the automotive field, can you charge more? Yeah. Why? Because you know what you're doing. You're going to be able to figure out cars that other shops can't. Okay. Now, there's a downside to that. Okay. And a lot of times your ego gets in the way. We're considered the 1%. So a lot of the cars that Jose and I work on are cars that have been to 4 or 5 different shops, a couple of dealerships, and they can't figure it out. Now the problem with that is when we get it, we're sold on we're gonna figure this freaking car out, right? The problem is you're charging 1 hour for diag. If you can't get it in that 1 hour, the likelihood of the customer wanting to pay extra time is very slim. So you need to really know what you're getting yourself into, right? There's been a lot of cases where we get cars in. First thing we do is we tell the customer X amount of hours to get the car back to stock in order for me to start checking. Because the other shop who checked it did a mess, right? So those are things you got to keep in mind. But on the other hand, when we do get those cars in, we could charge a premium because nobody else could figure it out, right? And then typically it's something super simple. Bad terminal, right? Or like right now we have a Durango that came from two other shops. Typical had a misfire. They threw plugs at it, coils at it, and it needs a timing chain. So nobody bothered to check mechanical. It's always ignition related problems, right? So those are the kinds of deals that you can be getting into being a specialty tech when it comes to electrical. Okay. The other thing is, for those of you guys that don't know me, again, my name is Oscar Gomez. My mission in the automotive industry is to better the industry one technician at a time. Everybody who's watching this today, plus you guys being here today, that's helping us help the industry. Also, I'm a firm believer in education. The more you educate yourself, the more you can make on your investment, right? The higher you are on your education level, your knowledge level, the more you can charge, okay? And as always, I always share my story. I started at the bottom just like everybody else. I didn't just wake up one morning and knew how to read wiring diagrams. This shit took forever, took a while. But with the mentorship of Don Wilson, who was my instructor when I went to school, and he helped me become a diagnostician and also helped me become an instructor. Um, Now, from going forward from that, I've had the privilege of learning from a lot of very intelligent instructors, Rick Escalambre, Jim Morton, Mike Clary. So there's Brandon Steckler. So there's a lot of big names in the industry that we all do the same. We pay it forward. Okay. So these guys have taught me a lot more, and I pass it on to you guys. Okay. So again, if you guys ever decide that you want to do more than turn wrenches, I would strongly suggest you guys look into becoming an educator. The more we can educate people in this industry, the better this industry is going to become, right? I don't know about you guys, but most of the guys I've ran into are parts changers, right? Car comes in with the code P0171. What is it getting? Set of O2s. If that doesn't work, let's throw some fuel injectors at it. That don't work, fuel pump, right? And they're just going to keep going down the list. They feel like an auto parts store. So we need to change that up, right? We got to test, not guess, okay? So I always use this one too. This is a good analogy. My mentor told me that your mind is just like a parachute. It only works when it's open. Okay, so what I want you guys to do is open up your mind for these next couple of hours. Let's take in this information so this way we can help you guys become better with electrical and pass your A6. Okay. All right, so I brought this up from ASE. ASE says that in order for you to pass the A6 exam, you guys need to have good knowledge on general electrical or electric, battery and starting system diagnosis, charging system diag and repair, lighting system diag and repair, instrument cluster driver information, and body electrical diagnosing and repair. Simple, okay? Most cars have all these systems now. It's our job to diagnose them, properly diagnose them, and then repair them, right? Back in the day, and I was sharing this with my class the other day, what a lot of older techs don't realize is that the reason why they always consider the computer the problem, because the computer didn't exist back in their day, right? And last week I was teaching some classes out in Florida, and I brought this up to the students that were there. If you got taught by an old timer, the old timer always blames the computer. And the reason why is because when they worked on cars, computers didn't exist. So they never had that problem up until the computer became part of the equation. So what's going to be the problem? What's the end result? It needs a computer, right? Because in their mind is, when I worked on carburetors back in the day, we didn't have this damn computer thing, so the computer thing must be the problem, right? And then that's where me and Jose came up with the rule of three, right? You replace 3 coils, 3 injectors, 3 plugs, 3 modules. If that doesn't take care of it, send it to the dealer, right? So that's usually how they end up. I don't have it with me, but cars usually show up with a box of goodies, which is all the parts that somebody else already replaced, right? And it's usually in the passenger seat or in the trunk. And when that happens, that's when we know we're going to be charging more. Okay, that's because whoever was working on it had no clue what the fuck they were doing. Sorry, I cuss when I get excited, so it just happens, right? So going on from there, these are statistics directly from ASE. So ASE says that there's 173,213 certified automotive technicians. There's something wrong with that number. Okay, how many techs are there in the whole US? And out of all those techs, or what they consider themselves techs, there's only 173,213 who have at least one ASE? Nothing, right? And most of the time, I'm actually part of a group on Facebook that's called ASE. And in that group, most of the guys who are in there, well, not most of them, but a lot of the guys that come into that group are like, oh, those tests is just a piece of paper, this and that. Yeah, that's true. But at the same time, that's how we know where we suck at, right? Okay. And why do you want to know where you suck at? So you can improve. Okay. On the other hand, me as a shop owner, I want to know where my techs are weak at. Because if I know you're weak in electrical, why the hell am I going to give you an electrical diag? But if I know that you're the shit when it comes to suspension noises, where you can find it with a 1/4-inch vacuum hose, I'm going to give you all the fucking suspension problems. Does that make sense? So me as a tech, if I understand where I'm weak at, I can relay that to my shop owner. Like, hey, you know what? I don't give me any of that work because I suck at that. Does that make sense? Okay. It's just like I told you guys earlier. I know what my specialties are. You're never going to catch me teaching a class that's outside of my specialty. Because if I do, I'm going to feel like an idiot. So I'm probably going to give you wrong information. Or if you ask me a question, I have zero experience with that. So how the hell am I going to answer your question? Does that make sense? Okay. Out of all those ASE techs, there's only 63,618 ASE master technicians. Does that mean you're better than anybody? No. That just means you took 8 tests and you passed them all. Okay? That doesn't mean you're better than nobody else. But because you took those 8 exams, now you know where you're weak at. Now you know what you got to fix. It's just like when we test a car and we do a relative compression test and we see that we have one weak cylinder. Why am I going to fix the other 6, or excuse me, the other 5 when I know only one of them's bad? Does that make sense? Okay. So it goes back to that same concept. If we know where we're weak at, can we fix that? Yeah. And if you don't know where you're weak at, you're going to pretend you're not weak. Okay. Because I hear this shit all the time where people tell me, I've been doing this for 35 years. I don't even know how to use that shit. Okay, cool. Right? Okay. Perfect example. Jose was in my diagnostics class, so we were using scopes. And there's so much pushback with scopes. I know a lot of techs who are like, I don't need to use that. Okay, so can you please explain to me how you're fixing these types of concerns? Okay, we had a Kia in here the other day. We had a problem with the intake manifold runner. We looked up the service information. Every section of the service information was a lap scope capture. So if you don't know how to use a lap scope, how are you going to diagnose it? Okay, there was about 28 steps. Each step had a lap scope capture. So if you don't know how to use it, what are they going to do? Exactly what one person told me when I mentioned this in another class. He said, we already replaced the intake manifold. We already replaced this. We already replaced that, and it's still giving me the problem. The only thing they didn't replace was the sensor, position sensor. But how are they going to check it if they don't want to use scopes? Does that make sense? So those are the kinds of things that we need to keep in mind about how we're going to go about things, okay? So these are the different types of ASCs that you need to take in order for you to be a master tech minus A9. A9 is additional, okay? So if you want to be an ASC master tech, you need A1 through A8. Right now I'm working on world, global master tech or world something tech. I'm 6 short of it. So that's about 20 ASCs, okay? So once you have that done, you're done. We're not done, but you can keep going if you want. I think it's presidential status, and that's like 56 ASCs. Okay? Nah, I'm not that crazy. So I'm not going to go for that one, but yeah, you guys could definitely go for it. Okay? All right. So if you guys have any questions throughout any of it, make sure you guys ask. Don't leave here with that one notion of, damn, I should have asked. Okay? Go ahead and ask. If I don't know the answer, that means that's a really good question. Okay, and what we're going to do is we're going to go ahead and figure out what the answer is together. All right, and if I still can't figure it out, or we can't figure it out, then I'm going to take your email, and then I'm going to ask some smarter people than myself, and then we'll get you guys an answer. All right, so let's start off with some of the basic stuff first, because automotive electrical and anything in automotive is all basics, right? How many of you guys have ever sat in an advanced electrical class? Any of you guys? Okay. I always bring this up, and other educators are probably going to hate me for this, but an advanced electrical class, there's nothing advanced about it. It's just a name. Okay. If you ever sit in a class, like a class that I put out and it says advanced on it, it's not advanced. There is no such thing as advanced. What is advanced? Advanced is you knowing the basics at a different level. Okay. So once you master the basics, you're actually at the advanced level. Okay. And I can guarantee you that because I've taught and I've sat in advanced classes, and all it is the basics. That's it. Okay. So first things first, what's voltage? Pressure, right? Or potential. Is that true? So let's think about that. Inside of a battery, what's inside a battery? I know we got lead, acid, and water, right? A mixture of that. But what is inside chemically inside the battery? Voltage, right? That's why we call it a voltage maker, a pressure maker. So your battery stores how much pressure in it. Okay? How much, whatever the voltage is, right? What is the 100% state of charge of a battery in a car? 12.6, okay? So when a car comes into the shop, if I take my voltmeter and I put the red lead on the positive side, the black lead on the negative side, what am I reading between those two leads? Potential difference, right? Because there's a difference between positive and negative. So when my voltmeter across it, I should get 12.6 volts, okay? If you guys look back there, look at my artwork. 75% state of charge is 12.4. 50% is 12.2. Okay, I remember back in the old day, all the old farts used to tell me if it has 12 volts, it's good. What's 12 volts according to my chart? It's dead. Okay, our rule in the shop is anything under 12.4, we're not touching. We're putting it on a charger or we're selling you a battery. Okay, why? Load shedding. Okay, if you don't believe me, have you ever had your alternator go out when you're driving down the road? Okay. If your alternator goes out, first thing that happens is you start losing all the non-essential shit like AC, your radio, speakers, okay? Why? Because the computer is prioritizing power for your emission system, ignition system, and fuel system. Once it can't sustain it, it says, and just turns everything off, right? If that's happening while you're driving, can you imagine if you're trying to diagnose a car with only 12.2 volts? The system you think might be bad is actually off because the PCM or the BCM, the body control module, turned it off. Okay? So that's why we got to keep that in mind. If you guys are going to be doing any type of voltage testing, this is how you're going to set up your meter in parallel. Okay? And this is important because you're going to see a lot of this stuff on the ASE exam. They're going to give you a picture like this. Okay? What are they measuring here? Potential voltage. Why? Because I'm not in circuit. It's basically like taking this 9-volt battery and going across it like this, right? That's all I'm doing. I'm measuring the difference between negative and positive on this one or positive and negative on a car battery, right? You'll also hear it as EMF, electromotive force. So voltage is always the pressure that's behind the flow of current, okay? So we need to understand that. Voltage doesn't flow, okay? What flows? Current, okay? So voltage is just a pressure pushing current through a circuit, right? And that's important that we understand that. So voltage is always referred to as EMF, volts, or potential, okay? Or pressure. We call it electrical pressure. I actually did a video on that, and I got a lot of shit talked to me because people said, that is not true. Voltage is not electrical pressure. So me being me, I obviously looked it up. I gave them a screenshot of it, and I posted it. After that, right? So that just goes to show how many people are not competent in electrical, but they swear they are, right? I had one guy who was like, man, I'm like 60 years old. I've been doing this shit since I was 15. Like, well, fuck, been doing it wrong since you were 15, buddy. Okay. All right. Next one is amperage. Amperage is considered flow, okay? So anytime that I'm testing an electrical circuit, and Jose can vouch for this, during my electrical class, all I talk about is current. Because us as techs, we shouldn't care what voltage is. I want to know what current is. Why? Because current is what actually does the work. Does that make sense? Okay. So if I have flow of current, do I have a good working circuit? Yeah. If I have an increase in current, do I have a problem with the circuit? And if you're not sure, you can look right over here. If amperage goes up, what went down? Resistance. Okay. And if amperage goes down, what went up? Resistance. Okay. So if you want to test a circuit the easiest way possible, that is checking current. Okay. All we're doing is checking for the flow of current, right? And that's how we're going to know if the circuit's good or not. Okay. So this is how I remember resistance. What do you guys see right here? Traffic. Okay. Some of you guys came from LA, so you know exactly what the hell traffic is, right? If you guys think our traffic's bad, I was out in Miami last week. Holy shit. Okay. It took me 35 minutes to go 4 miles. Right? Then it took me an hour and 30 minutes to go 15 miles from Miami to Fort Lauderdale. Okay. So if you think our traffic's bad, theirs is worse. What makes theirs worse is they don't know how to drive. Okay. It's crazy. And if you guys are from Miami online, I'm terribly sorry. We suck at driving too. All right. So when it comes with resistance, resistance is anything that impedes or slows the flow of current. Okay. So just like you guys could read up here, if resistance goes up, so that means traffic goes up, can your speed go up? What happens to your speed? Drops. Okay. If resistance goes down, so traffic dies down, can you go faster? Yeah. Okay. And this right here is explaining to you how we have a problem with the electrical circuit. If a car comes into the shop with a blown fuse, what happened? What changed? Resistance. If I have a blown fuse, that means I overheated the circuit because I had too much flow of current. If I had excessive flow of current, what dropped? Resistance. Does that make sense? Okay. So we need to understand that. Well, that way when we're reading any questions, because we are going to do some Q&A at the end, okay, that way we can answer these questions, all right? So just like you guys see up here on my chart, we have it up here as well. If resistance goes up, amperage goes down, okay? And the way I remembered it was with traffic. Traffic goes up, speed drops. Traffic dies down, I could go as fast as I want until I get pulled over, right? Okay? So when we're looking at a circuit, there are a couple different things that make a complete circuit. What are they? Let's break it down. Do we need a power source? What is our power source in a car? Battery. Good thing you guys didn't say alternator. The alternator's responsibility is to do what? Charge the battery. Or if it fails, to drain the battery or make your diag living hell, right? Okay, because if we have a bad rectifier bridge in the alternator, what are we going to have throughout the whole system? AC ripple, okay? So that could be a problem. Battery. From the battery, we have a circuit that goes up to our fuse. What is our fuse? The answer I want to hear is circuit protection. The fuse is there to what? Protect the circuit. Is that true? Okay. Except if you bought them at Harbor Freight. If you bought them at Harbor Freight, you're going to melt the shit out of the wiring harness before the fuse ever decides to melt, right? Okay, so we got a fuse. What do we have after the fuse? Switch, okay? Looking at this diagram, in what position is that switch? Is that switch open or closed? Open. Why is it important to understand that? That's where it's going to stop, right? On the other hand, as a tech, if I'm looking at this diagram, what am I expecting to see across that switch? An open or a closed switch? Open. Remember, however you see your diagram is how that vehicle is in its normal condition, normal config, right? So normally this switch or this circuit is going to be open. The only time it's going to close is when I either manually close it or some sort of electronic phenomenon closes that switch, right? So if I go test this, I should expect this switch to be open because that's how it is on the diagram. From there, what is this? A load. What's a load? Anything that consumes current, right? Could that be a light bulb, fuel pump, a relay, heads-up display, right? Could be anything. Anything that consumes current is going to be what? A load. And then after the load, we're going to have a circuit that returns current back to what? Ground or the battery, okay? When you guys are dealing with automotive electrical circuits, we use a theory called electron theory. Excuse me, conventional theory. Shit, I had a brain fart already. Okay? What that means is it leaves from the positive side and returns back to the negative side. Okay? Why is that important for you to understand that? Because the other theory is electron theory, which states it goes from negative to positive, which in reality is how electricity flows. The problem is in automotive electrical, we flow from positive to negative. So if you're using an amp clamp, does everybody know what an amp probe is, an amp clamp? Okay, those are directional. So if you don't understand the flow of current, when you put it on, it's going to be backwards or negative current, which is not possible unless there's a potential difference. Okay, so we need to understand the flow of current. Does that make sense? Okay. What type of voltage are you guys going to see anytime you're working on anything electronic? Just like the band, AC/DC. Okay? There's a major difference between the two. DC volts is only going to ride above 0. It will never go below. Okay? AC voltage, on the other hand, what can it do? It's going to alternate up and down, negative and positive. Okay? Now, there's a couple different attributes when it comes to volts AC. Okay? Most of the time, everything you guys are going to check on a car is going to be what? DC volts. Okay? There are going to be a couple times where you're going to have to check some AC voltage stuff. Where would that be? What if you got a 2-wire permanent magnet style cam sensor? Is that going to be an AC voltage? The answer is yeah. Okay, it's going to give you an alternating waveform. What if you have a 2-wire ABS wheel speed sensor? Is that going to be that kind of waveform? Okay. So if you're dealing with a waveform that looks something like this, you can use not only a lap scope, you can use a voltmeter. Isn't that true? Okay, if I put my voltmeter across the 2-wire sensor and I put my voltmeter to volts AC and I crank the engine, I should expect to see at least 1 volt. Okay, if I'm not getting at least 1 volt, there's a problem with that sensor. Right? That's for my non-scopers, but you guys are here, so what are you guys going to use to check one of these? Scope. Okay? And this is how I'm going to find out if you guys like scopes or not. How many of you guys would prefer to read something on Google or watch a YouTube video? How many of you guys prefer YouTube? Obviously from a good source, right? Okay? So if you're watching YouTube, you're going to love scopes. Why? Because I know you're a visual learner. So if you love visual representation, so you're going to love a scope. Okay? So a couple different attributes to AC voltage. One, as speed increases, okay, you're going to have amplitude increase and frequency increase. When we're talking about hertz, we're not talking about the car rental place. We're talking about frequency, okay? So hertz is a measurement of how many times the signal repeats itself within 1 second, okay? And if you guys look at this diagram here, notice how we have this 1 dot, got 1 here. So that would be 1 hertz because this repeated itself 1 time within 1 second, okay? The other thing is amplitude. Amplitude describes voltage increase or lowest to highest potential, right? On an AC voltage waveform, if it's a wheel speed sensor, as the wheel begins to speed up, we're going to have amplitude increase as well as frequency. That means it's going to happen more and more often, right? As it slows down, amplitude comes back down and then frequency decreases, okay? So that's how your ABS module can determine if you have a bad ABS wheel speed sensor, or if you have a wheel that's slipping due to dirt, water, right? Or if you're running a donut on one wheel and you got 3 good tires on the other, that donut's going to spin faster than the other, right? Okay. So we need to remember that when it comes to AC volts, we're always going to be looking at hertz along with amplitude, okay? Any questions so far? Beer? Already, bro? We just got started. What do you mean? Okay. So earlier you guys told me that your battery is your main power source. Is that still true? Okay. What kind of test can you guys run on a battery to verify if the battery's good condition or not? We can scope it. Okay. I'm a firm believer in using a scope. How many of you guys know the difference between a dynamic test and a static test? Because there's a difference. Okay. So let's break those two down. A static test would be using that $2,000 tool you bought off the tool truck that connects across the battery and the car's off, and you just push a couple button sequences and then it tells you battery's good or bad. Okay. Did you ever stress that battery? No. So all it did was run an algorithm based off of the internal resistance or capacitance of the battery. That's how it determines if the battery is good or bad. Okay. We've had a lot of those tests that turn out good, and when we scope it, they fail. So now the other test is a dynamic test. What a dynamic test is you're testing the system or component in its normal configuration. Okay. Wouldn't that be a much better idea? Wouldn't it be a better idea to test the battery, starter, circuitry, and the engine by using oscilloscope over the battery? Right? Okay, I always use this example. In the medical field, they don't tell you, you know what, we got to run some blood work on your liver, so we're going to go in surgery and pull that shit out, send it off to the lab. When I get it back from the lab, then we'll know what's wrong with it, and if it's good, we'll throw it back in you. Right? No, they don't do that shit. But you know how many shops do that? Well, they're going to use their little $2,000 Game Boy that's going to give them a little receipt and says if the battery's good or not, right? It's a waste of time. Okay, with the one test we can run, you connect across the battery, positive, negative, like that. That's all you do. And then crank it. Car starts up. During initial crank, shouldn't drop more than 8.5 volts. If it does, you got a weak battery. Then after that, you're going to see some commutation bars, which is when the engine's going into compression. Then you're going to see the alternator excite, alternator kick on, start charging. Beautiful. One capture. You tested what? Battery, ability to crank the engine, engine compression, and alternator with one test. Okay? Obviously, when you print that, customer's not going to have any idea what the hell it is. But once you compare a bad one to a good one and you show that to a customer, they're going to be jacked. They'll be willing to pay you $200-300 for that. Does that make sense? Okay? Versus they went to that guy down the street that closes after 5 because that's when the state's not working anymore because they don't have licenses, right? The other thing is a ground. So what is the largest ground on a car? The car, chassis, okay? How many of you guys have ever done a voltage drop test from the battery negative to pin 4 of the DLC? Okay, and why is that a good idea? If you haven't done it. Pin 4 is chassis ground. So if I have a problem from the negative side of the battery post to pin 4 of the DLC, doesn't that reflect the whole freaking car? So if your whole car is the ground and you have a problem up until the DLC, is anything else going to work on the car? No. Okay. So if you ever have a car that when you step on the brakes, like your wipers turn on and shit, okay, that's a ground problem. Okay. And I've seen stuff like that. Matter of fact, I have a capture up here in a little bit where you were present for this. One of our students brought in her car. On the way here, she was complaining about some issues with it. Yeah. Okay. And all they did was run 2 tests and they found the problem. 2 tests. I'm not saying we pulled out lab scopes. We pulled out a voltmeter and they found the problem. Okay. And what was it? Bad ground. Right. It looked good, but it didn't test out good. Right. You'd be surprised how many batteries we've replaced for problems where people are like, nah, it can't be the batteries. Like, trust me, it's the battery. Okay. People don't realize that a battery could give you a lot of problems, especially on a car that's like electric, right? Because most cars are electronic. Okay. So ground, we need to have a good ground. It needs to be clean. It needs to be efficient. It needs to work properly. Okay. I'm going to turn off so you guys can see these real quick. We need to make sure we have good terminals, right? That's another thing. If you guys are a shop and I ever catch you using universal terminals or emergency terminals, I'm going to smack you. Okay? You don't use those. You guys are professionals. You either replace the whole cable or you make your own. You don't use that shit. Okay? You leave that to the kid that goes on forums on fucking Google and listens to some kid in the Philippines about how to fix his car. Okay? Let him do that, not you. And how dare you put those shits on and charge a customer for it? Okay? What you guys should be doing is you need to buy 00 or 0 gauge wire, right? Buy a crimping tool, buy some cable lens, and make your own. That looks way more professional. Okay? This is the shit I'm talking about. Okay? You'd be surprised how many cars show up from other shops. They say, oh, battery's good. And it looks like that. Okay? We fixed cars that had 7, 8, 9, 10, 11 volts on the case. It's plastic. Plastic was holding voltage. That's just telling you the battery's leaking. Okay? But nobody fucking bothered to check that. They say, no, it looks good. How the hell does that look good? And then people wonder why we have a bad reputation as auto repair shops and techs. Does that make sense? Okay? Jose fixed one today. Right? And it came from another shop. I didn't want to say that, but yeah, it came from the dealership. Okay? And it's again, it goes back to you got to understand what you're doing. Right? Okay? How many of you guys have heard of this test, the continuity test? Where you put your meter in resistance and then you test the circuit. You guys ever seen that before? Yeah. Right? You probably taught that. And I'm going to be the first one to tell you, the only time you're going to do a continuity test is if you're testing pin 6 and 14 of the DLC for an open terminating resistor. Outside of that, you're probably not going to use it. Okay? Or at least I'm not going to show you how to use it because that's a waste of time. Okay. Or if you're trying to pinpoint an open circuit like we were doing here in class, like that. But outside of that, you're not going to use this. The reason being is, am I loading this circuit by doing this test? No. Okay? And I have a video where I did this same test. Okay? I took a piece of 14 gauge wire and I took one strand out of that wire. And I tried to run 10 amps through it. What thing happened? Burned up. But when I did a continuity test, tested fine. Okay? So why are we going to do static testing when I'm not stressing it? Wouldn't you rather stress the circuit to be able to know? Right? Okay? I gave this example the other day while I was teaching a class. Everybody know what a stress test is, right? Where they put all these gadgets on you and shit, and then they make you run on a treadmill like they're about to kill you, right? To see how much you can take. Can you imagine doing a stress test on a lazy boy, drinking a beer, watching Netflix? Is there going to be a difference between those two stress tests? Okay, so that's a continuity test. Sitting on a lazy boy, drinking a beer, watching Netflix, right? And then you're wondering like, oh, I'm good, man. Look at my heart rate. It's fucking gangster, right? But then they throw your ass on a treadmill and you're dying, foaming out the mouth, all kinds of crazy shit. Does that make sense? Okay, so that's why this kind of test doesn't do anything for you. You're wasting your time and your customer's money because this test is not going to tell you shit. The last time I used this test was to verify that I had a short circuit to ground. That's it. Okay? When we have an open circuit, what is that referring to? Do you have flow of current, no flow of current, an open path? Could that be a corrosion? If it's bad enough, it could be, right? If it's not, what is that adding to it if you have corrosion? Resistance, okay? When we have an open circuit, we have a broken path, right? Now, there's two different types of open circuits, intentional and unintentional. What's an intentional open circuit? Could that be a switch or a relay? Yeah. Right? When I turn off my headlights, didn't I intentionally open the circuit? Okay, so that's intentional, right? But what happens when you have Joe Schmo who just smoked some weed, now he's working on your car, forgets to put a ground on the back of the engine block. Now that whole ground circuit's open for the whole engine harness. Now the car won't start. Was that intentional or non-intentional? That's an unintentional missing ground, right? That's an open circuit. Okay? Jose's laughing in the back. Oh shit, that's a good one. So we recently we had some retard who brought a truck in, and he did a front end conversion. So he modified the front end to a newer style truck. Somebody told him that plastic was a good conductor of electricity. Okay, because he took a ground strap and bolted it straight to plastic. Right, keys wouldn't program, PAT system wouldn't work, truck would crank but wouldn't start. Right, the way we figured it out. And I helped about a quarter of the way, and then I had to take off, but Jose finished it up. We did a voltage drop test from the ground side to pin 4 of the DLC. We had close to 3 volts loss between ground and the DLC. Pin 4 of the DLC was that same ground strap that this moron put to plastic. Okay? So all Jose did was he moved it, he put it on the stud next to it where it needed to be, right? Cleaned it off, ground it out, put some stable in 22 on there, and the shit took the key programming, didn't lose programming, PATS codes went away, and the shit started up. Okay? 1 ground. Right? So those are the kind of problems you guys might run into. Okay? But that's how you can figure it out, is simply by understanding, do I have excessive voltage drop? If I do, then I know I have a problem within that circuit. Okay? This is how I remembered an open circuit. You think a train's going to get across that? If it goes fast enough? Okay? Crackheads got to it, man. Right? They gotta pay scrap metal. They couldn't find any cats, so they said, fuck it, we'll steal some railroad ties. They're ruthless. All right? So just like we have here, if this is open, I can't have current flow into this load, right? If this is open here, I can't expect the train to go from point A to point B. Okay, this is how I remembered an open circuit. Okay, so what I'm sharing with you guys is how I remembered it. So this way, when you guys are in the field or taking a test, you can relate to that, right? You read anything about an open circuit, what are you going to remember? Okay, train tracks, okay, or something unplugged. Very simple. Okay, don't overcomplicate it. Does that make sense? Okay, did you guys notice that we haven't talked about atoms and valence electrons and all that bullshit? Okay, you know why? That's not going to help you fix a car. Okay, you're not going to go to a customer and tell them, well, sir, ma'am, I checked your car and you got 6 billion electrons flowing from point A to point B, and that's why we got this problem, right? No, it's you got an open circuit, so we have no flow of current. Does that make sense? Obviously, if you're going to be teaching this at a university level, yeah, you probably want to know the physics behind it, but we fix cars, right? And talking about valence electrons and positive and negative nucleuses and all that shit's not going to help you fix a car. Does that make sense? Okay. So we got to keep it simple. The other one would be a short circuit. Somebody lost a finger? Ah, oh, damn it. They need a rag and an electric tape and move on. Okay. Whenever we have a short circuit, what do you call that? If you don't know, look right here. If I have a short circuit, what happened to my resistance? Did it go up or down? Down. Okay. Whenever I have a short circuit, we're going to look at it this way. What a short is going to do is, instead of electricity flowing through these loads, which is difficult, what is the electricity going to do? It's going to go straight and take the shortest path back to ground. Okay? Electricity is lazy, right? Think of electricity as like a 16-year-old that all they do is play video games all day. You tell them to take out the trash, and they give you every excuse in the book. Okay? That's what electricity is. It's freaking lazy. So it's going to look for the easiest path to get back to ground. So if I have a short circuit that bypasses any load, isn't that the best way for electricity to get back to ground? Yeah. Okay. But at the same time, because now I don't have a load or resistance to slow the flow of current, current is going to flow a lot faster. What is a byproduct of current? Heat. Okay. So if I have excessive amount of current flow, is that going to create heat? Is that going to melt a fuse? See how that goes hand in hand? Okay. So whenever we have excessive flow of current, we're going to create enough heat to the point where it's going to melt that fuse. Okay. So that's when you're going to know, okay, cool, I have a short circuit. I don't know where, but I have one. Okay. So then your job is to figure out where it's at. Could it be a component? Sure. Could it be a circuit? Definitely. Okay, could it be the last retard who worked on the engine and put the main harness connector upside down? Definitely. Okay, it could be a lot of that. Okay, all that shit happens. So your job is to figure out where it's at. Okay. So I put this in here so this way you guys can see this for test reasons. This one right here. How am I testing this circuit? We're in ohms, so we're doing a continuity test. Do you guys agree? Okay, so right here, what the voltmeter is doing is it's just checking resistance from one point to the other. That's all it's doing. Okay? And the reason I'm pointing this out is because when you guys are taking your ASE or any automotive electrical exam and they give you a diagram like this, first thing you need to do is look at what the meter's testing. Is it voltage? Is it current? Or is it resistance? Does that make sense? If this meter is checking resistance, what is it called? What is a meter called? An ohm meter. Okay? We all know it as a digital volt ohm meter or a digital multimeter, right? And I agree with you on that. However, when you're taking the test, if you're checking ohms, what meter are you using? An ohm meter. What if I'm checking amperage? Ammeter. What if I'm checking voltage? Voltmeter. Congrats, you got 3 right. Okay, you're almost there. Okay, now you just need 30 more. Okay, so this one right here, we're also doing a conductive path. We're checking continuity, right? But now we're gonna have some sound to it. If it beeps, do we have flow? Yeah. Okay. What about this one? Why is it not beeping? It's open. There's no flow. Okay. Do you guys see where we're getting at with open? It's like our railroad tracks that the crackheads cut open. It can't get across. Okay? So we can't have current flow going across it because we can't have current flow. What does that mean? We got an open circuit. Okay? How many of you guys are comfortable with the way a parallel circuit is and a series circuit is? Okay, they're not going to test you on this, but I just want to make sure you guys are okay with that. When we're talking about a series circuit, how many passive current flow do you have in a series circuit? 1. Okay? Do they all share voltage? Somebody said Christmas lights. Good answer. Okay? In a series circuit, if I start with 12 volts, is it going to start subtracting based off of the amount of loads I have in the circuit? Yeah. Okay? Depending on the resistance value of each load, it's going to start taking away voltage until we get to what? What should be our voltage at the end after the last load? 0. If you don't have 0, what does that mean? That means you have unwanted resistance somewhere. Okay? Because wouldn't you agree that after the last load, I should use up all available voltage on this series circuit? So I got 3 light bulbs. Wouldn't all 3 light bulbs use all 12 volts? And if they don't, that means you have a bad circuit somewhere after the last load, which typically is ground. Right? Okay? On a parallel circuit, each one of these is individual. If I lose this one in the middle, can these 2 still work? Yeah. Okay. So on these right here, the way you're going to work these is each one of these is going to have its own current. Then you're going to add up the current for a total, right? Have you guys ever fixed a car that some kid put some LED lights or some shit that he got for Christmas in the wrong circuit, and then he starts complaining about blowing fuses while they're driving down the road? Okay. Typically, when somebody who doesn't know what they're doing installs electrical components to a car, the way they find the right power source is they just look for something that has power. They don't know about current. They don't know about resistance. They don't know about parallel circuits, right? So based off of this, let's say these 3 are transmission shift solenoids. All of a sudden, your customer saw a wiring diagram from some Filipino kid on a forum somewhere, right? He wires in some LED lights into those shift solenoids. What's going to happen when he turns on his LED lights, which are now consuming more current, adding more load to the circuit, and then all of a sudden the car shifts and then activates the torque converter? Now you have 2 solenoids that were operating with a third being your LED lights when they weren't supposed to. Now it just overheated the circuit. What's going to happen to the fuse? Pop the fuse. You think he's ever going to go back and think like, what did I add to this before all this shit started happening? No. They're going to take it to you. Then he's going to be like, I don't know what's wrong with it. It keeps blowing the transmission fuse, right? Then you're going to think, oh, shit, this probably needs a trans. Probably needs a valve body, right? But then once you go look at the fuse, you're like, what the hell is this, right? You just see somebody shove the wire in there and then shove the fuse in there to hold it in, okay? So that's why on a parallel circuit, if you add another load that's not intended, you're going to blow a fuse. Does that make sense? Okay. How many of you guys know by memory, if I were to tell you you're looking for ground G209, where is that located? Under the dash, right? If I tell you to find connector 102, where's that going to be? Under the hood. What if it's in the 400s? Trunk. Okay. So during my class, I talk about the 85-15. 85% of things on cars are the same. 15% is how do the manufacturer use it, right? This is one of those things we need to know right off the top of our head. Because if I'm looking at a wiring diagram and this shit says that I'm looking for connector 202, I know it's going to be under where? The dash, right? And if I'm getting paid to diagnose the car, at that point, what do you think I'm doing? I'm calling the customer. Hey, you know what? I got to take your stupid dash off. It's X amount of hours. You want to pay for that? I can't check your car until I take the dash off because the connector I need to get to is underneath the dash. Right? But if you don't know that, what are you going to start doing? You start looking for that connector. Right? Then 3 hours later, you're like, oh, shit, I got to take the whole HVAC box out because it's behind it. Okay? At that point, you're committed. You think you're going to call a customer and ask for 4 hours disassembly time at that point? No. Because you already spent 3-4 hours trying to figure out where that connector was. Okay? Then that's why customers get that expectation, and that's when they get their hearts crushed, right? Because we screwed up. Okay? So part of our job is to kind of understand where some of this stuff is, where my test points are, so this way I can call that out from the beginning. That make sense? Okay? So we've had to call a customer and tell them, hey, we got to pull the dash out. But that's just for me to get in there and keep checking. The 1 hour diag, I haven't even started that yet. I got to take your dash out before I can start that. Okay? Why is it better to tell them that from the get-go? So you don't waste your time. If they don't want to pay you, see you later, come pick it up. Take it to Joe's garage down the way. Pretty sure he'll break it, figure it out. Right? Okay? Or sometimes we send cars away. And what's freaking hilarious is it comes back. But you know who brings it? Another shop. The shop that they took it away from us to go take it to the other shop, that shop brings it to us. And what's even funnier is the customer comes to us to pick it up. He's like, what's up, man? How's it going? I haven't seen you since the last time you were here. Okay? Since the first time you were here. Okay? When you told me you didn't want me to fix it. Okay? So, dynamic testing. Here's how we're going to do this. I want you guys to look at these two, and we're going to analyze these for test purposes. So this first one over here, my voltmeter is set to what? Ohms. Okay? So now I know that this is an ohm meter. Do you guys agree? Okay? If I have my ohm meter set to the output side of the bulb to ground, and I'm getting 0.005, so 5 milliohms, what does that mean? Is that circuit intact? That's voltage drop. That's voltage. You're right, but that would be voltage. What makes it different is where we have our meter set to, right? So we're checking ohms. Ohms, this should be at 0, right? So because we're near 0, does that mean that circuit's okay? Yeah. Can it carry a load? I don't know. But according to my continuity test, is that okay? Yeah, right? Now, if I go to the next one, we're still checking resistance. We're still in the same connection, but what does my meter show? OL. Because it says OL, what does that mean to that circuit? Is that circuit in good shape or not? No. That circuit's open. Does that make sense? Could I have seen that doing a voltage drop test? Yeah. We're going to talk about voltage drop right now in a bit. Okay? But think of it this way. If that last voltmeter that says OL was on an ASE test, and you're taking the test and you're like, freaking idiot, I would have done a voltage drop test. Don't do that. Because now you're going to start second guessing yourself. Okay? I remember I used to walk out of these tests and be like, whoever wrote those tests is an idiot. No, I was the idiot. Because I came up with answers that weren't even there. Okay?
Maybe it was the right answer too. It's just
yeah. And that's right. What I would do is I'd be like, oh yeah, I remember a car like that did this, this, and this, and it turned out to be this. Then I look at the 4 answers like, holy shit, it's not there, right? Then I'd be like, these guys are dumbasses. They don't know they don't know anything. It's like, nah, bro, it's you, okay? Because I was coming up with a whole different answer that wasn't even possible. Okay, what's the only possibilities? The 4 in front of you. Okay, so your job is to figure out, can these 4 answers fit this problem or fix this problem? Right? If you can't figure it out with those 4, you're wrong. That's it. That's the best way to look at it. Okay? So again, we have OL over here, and we're checking the ground side. So would you guys agree this ground circuit's open? Yeah. Okay. So at that point, we got to open ground. We got to repair that. What happens when I have a short circuit inside of an ignition coil? It won't charge up. Okay. What do most shops do when a car comes in with a misfire? You guys know right off the top of your head. Car comes in with a misfire. First thing it gets is coils and plugs. If that doesn't fix it, we're going to injectors. Right? If that don't fix it, send it to the dealer. Bless you. Okay? And what's the dealer going to do? New coils and plugs. Okay? Or piston rings or PCV valve. Right? How can we spot a shorted coil on a car? How can we test that? We need a scope and a paddle probe. Okay? Or can I use an amp probe? Okay? When I have a short circuit, okay, based off of what you guys know, if I have low resistance, what happens to my amperage? Okay, so if I'm looking at this on an oscilloscope, would you guys agree that I'm going to have a straight vertical line when current begins to flow into that coil? Because think about it. Current going up, right? If there was resistance, which there should be, it shouldn't be straight up. It should be on a ramp. So if I have a straight vertical line, what is that indicating to me? I have excessive amperage. The only reason I can have excessive amperage is what had to have happened in the circuit. Resistance drop. Drop in resistance equals a short circuit. Okay? We did that with the Nissan, right? You guys got to see the bad coil. Okay? On this one over here, if let's say this was a question on the ASE exam, and it tells you that this light turns on, or excuse me, we're going to say whenever you step on the brakes, it blows the fuse. Okay? So question states that this car comes into the shop because every time the customer steps on the brake, it blows the fuse. Okay? What should start going through your mind automatically? I got less resistance, right? Because I'm blowing a fuse. So if my fuse blows, then I have excessive current draw, right? So at that point, would you guys agree that you're on the right track now, because now you're starting to think, okay, where can I have this short circuit at, right? Where can I have this extra path of current flow? Okay. So now look at the diagram. Here's the fuse. What's next to the fuse? Switch. From the switch, when the switch closes, power flows out or current flows out, and that goes to brake lamps, right? So the moment that I step on the brakes, it blows this fuse. So this is telling me that this switch closes, allows current flow. So that means I need to have a short circuit either immediately after the brake switch or before this load. Is that true? Okay. So what you're going to do when you're taking the ASE test is look at where they have the voltmeters. They're usually going to have little meters coming off of it with measurements. Okay. So if they have a voltmeter right here where it says short to ground, and that meter right there is showing 0, 0, and it's from that point to ground, wouldn't that tell you that there's a short to ground there? So whenever I close that or step on the brake and I close that switch, what's happening? Instead of going to the load, the easiest path is to take that shortcut back to ground. right? That excessive flow of current overheats the fuse, and what happens to the fuse? Blows, pops. Does that make sense? Okay. I love this one. This car came into your shop. The customer's complaint is it has a slow crank. The old woof, woof, woof type style. Okay. What are you selling them? Battery, starter, right? Just to name a few, maybe a key in some instances. Okay. So what kind of test are we running here with our Harbor Freight voltmeter? We're on volts DC, right? Then look at your connections. You got one connection at the positive side of the starter motor, and the other one is on the positive side of the battery. What are you measuring? Voltage drop. Okay, so what we're measuring there is the voltage consumption between the battery post and the starter. Okay, while the engine's cranking, because you never do a voltage drop test statically, you got to load the system, right? So with the car cranking, we're measuring negative 1.27 volts. Why is it negative? Leads are backwards. That's the beautiful thing about a voltmeter. Okay, I've had students before that took my electrical class and they're like, nah, I don't want to touch that. I'm going to fuck it up. No, you're not. Okay, the only way you'll mess it up is if you have an old school analog meter, the one with the needle. Okay, don't use those. Those have low internal resistance. Yes, you'll fuck some shit up if you do that, right? But on one of these, we don't have that problem. They have high impedance, so you're not going to screw anything up. All you get is a negative reading. That just means your leads are on backwards, okay? So at this point, we're losing 1.27 volts from the positive side of the battery to what? To the starter. So what's the problem here? Is it the starter motor? Is it the battery? What are you going to sell your customer? New battery cable. Okay? And why are we saying that? Because look where we're testing. We're not testing across the solenoid. We're testing from the battery to the starter motor, right? So we're testing the flow from those 2 points. If those 2 points have excessive resistance, which they do, what's the only fix here? Battery cable. Okay? Now, if you're dealing with a newer car, some of these are part of the sub-engine harness. So what do you got to replace? The whole engine harness. Okay? Damn, Siri. Hate when she does that. So this is why it's important for you to be able to make your own cables. Because if you give the customer the option of saying, all right, well, it's going to be $2,800 for me to change the whole sub-harness because your battery cables are bad, versus I'll charge you $450 and we'll put new battery cables in there, and they're guaranteed for 12 months, 12,000 or whatever your warranty is. What do you think they're going to pick? The cheaper one. Okay? Or they might, or if you know a bucket shop, they might say, well, AutoZone has a universal one, right? Whatever's left over, we'll just zip tie it and hide it somewhere so you can't see it. Okay? But you shouldn't do that. You should be making your own battery cables, right? What do some of these battery cables have nowadays? They have an ammeter. Okay, if you guys haven't ran into them yet, if you notice some battery terminals have like a little digital sensor on there. That's an ammeter. It's measuring current. That's why some new cars, when you hit the button, nothing works. But you got to the store, now your car won't turn on. Well, that's because you have an enhanced flooded battery, and that ammeter detected that there was too much current flow. So the battery's weak, so it's not going to let the car crank over. No shit. Okay? Cars are getting smarter. Okay? Sadly, the techs that are not here are not getting smarter with those smart cars. Okay? You guys are, though. Right? Any questions on this voltage drop test? Because you're going to get a lot of this on the ASE if you guys take the ASE. Okay? And that's important because voltage drop testing doesn't just apply for tests. It also applies for you in the real world. Okay? You're going to fix a lot of cars with voltage drop problems. Right? And the famous ones are body shops. Okay? Okay, so here's what I want you guys to do. You need to memorize these. Not know them, not know where to look them up. Memorize them. You need them for your state test if you're going to take your smog repair exam, or if you're going to take an ASE, you need to memorize these. Okay? So, Voltage drop on the ground side should be 200 millivolts or less. Battery positive to starter, 300. Battery to alternator, 300. Battery post to terminal, 200. And across the starter solenoid, 300. Okay. You guys want to know of a money maker? Battery post to terminal. Money maker. Okay. Why? You know how many cars fell for that test? And then you present to your customer a battery terminal service, which is basically cleaning the whole battery, cleaning the terminals, cleaning the post, adding Stablant 22, reassembling it, calling it a day. You can sell that for a couple $100. Okay? Because think about it. What are you gonna weigh it against? Tell your customer, you don't want to do this, that's fine. You know how much a whole wiring harness costs to replace that battery cable? No, about $2,800. So would you rather spend $80, $90, $100 to get this cleaned up? Or, you know, you can always wait and then we could spend $2,800 later. See the difference? Okay, obviously I'm being very sarcastic, but when you're doing this at the shop, right, we got to sell value. So you got to show your customer why it's important to pay that extra money for that particular service. Okay? Or do what we do, just sell them a new battery. Okay? Sell them a new battery and clean the terminals, call it a day. All right. How many of you guys know what Ohm's law is or ever heard of it? Okay, so I'm not going to go into the details about George Simon Ohm, none of that fun stuff. Ohm's law simply says, walkie-talkies are going off again. Place is haunted. So Ohm's law states it takes 1 volt to push 1 amp through 1 ohm of resistance. Okay, that's what Ohm's law states. Now, this is going to help us understand better how the flow of electricity is going to affect circuits and how resistance is going to affect the circuit in its integrity or entirety. So let's look at these real quick, okay? Look at this first one. This first one, we got a battery. We're going to assume this is a 12.6 volt battery. We got a switch. We got 1 load, and we're going back to ground, okay? I have my voltmeter connected across the only load on the circuit, okay? What is my voltmeter measuring across that 1 load? 12.48 volts, okay? Would that be acceptable based off of you knowing it's a 12.6 volt battery? What's before the bulb that could be taking away some of that voltage? The switch. Is that possible where a switch is going to consume some of that voltage? Yeah, that's expected. Okay. So what we're seeing here, that means that this 1 bulb is using up all 12.48 volts. Okay, we good? We good there? So let's go to the next one. On this next one, we're connected across that same bulb, and my meter shows, what is my meter showing? 11.3 volts. Do you have a problem there? How do you know that? Okay, I don't know about you guys, but I typically like to finish with what I start, right? So if I start with 12.6 volts, shouldn't I end with the equivalent of 12.6 volts, right? So if we start with 12.6 and I go to my meter and I'm seeing 11.3, okay, and we're going to say this is an ASE question. Where's your problem going to be? What's the only thing on here that could be causing excessive voltage drop? The fuse or the switch? Switch, right? Look at your meter. You got a voltmeter set in volts DC showing 1.2 volts, and it's connected from the positive side of the battery to the output side of the switch. Okay? How would I be able to diagnose this on the field? Forget the test. On the field, how would you fix this? Okay, my mentor taught me you walk the meter. Okay, and that's exactly what I teach. What that means is I'm going to keep this red lead is the one I'm going to move, and I'm going to keep my black lead on the positive side of the battery. So now, if I take my red lead to the input side of the switch, and this voltage goes away, where's your problem? Switch. But what if I go to the input side of the switch, and I'm still seeing 1.2? So then I'm going to move it to the next point, which would be the fuse. If I go to the output side of the fuse and this goes away, that means that my problem is between here and here. Does that make sense? Okay. How are you going to fix that? Are you going to run a new wire, or are you going to charge them to open up the harness? Open up the harness. Okay? The reason being is you could run a new wire. I'm not going to fucking get on you for that. But what were to happen if that wire is bad because it's shorting out or it rubbed through? So when you run your new wire, okay, you overlay a wire and current goes back into that circuit, can you cause a fire? Yeah. Okay. Remember, you're professionals here in the state of California. So as a professional, you fuck up that bad, they could come after you civilly. Okay. And typically, you know who does that? Insurance companies. You do an electrical repair like that and you document it, and then the car catches on fire, State Farm will pay out the owner of the car, but then they want their money back. So who do you think they're going to come after? They're going to come after you or whatever shop you work for. Your shop's going to go down for you. Okay. So we got to keep that in mind. So when we're talking about Ohm's law, okay, we need to remember you're going to hear it a couple different ways. If you're taking it from a physics standpoint, it's E equals I times R. E is voltage, I is amperage, R is resistance, right? To simplify it, V equals A times R. What's V? Voltage, A, and resistance, okay? Most of the time, what we do is we're going to use voltage and resistance to figure out what my amperage should be, okay? Wouldn't it make sense that if I know I have a 12-volt circuit and I have an ignition coil that has 1 ohm of resistance, how many amps is that coil going to use? 12. Okay? And how do we figure that out? Amperage times resistance, and amperage divided by voltage or resistance by voltage gives you the other, right? So if I know I have 1 ohm of resistance and 12 volts, if I divide those, what am I going to get? 12. So if I go test my coil and I get 7 amps, what does that mean? What went up? Resistance. Okay? So your misfire is not going to go away if you replace the coil. Because your coil is only doing what it can do with what it has. Does that make sense? Okay, so this is why, and I preach this a lot, is you diagnose on paper first. You always start your diag on paper. Okay? Have you guys ever tried to do something like just following your own, what you remember? Okay? It doesn't turn out very well, right? Okay? Because then you're like, oh, shit, I forgot to do that. Okay? Or like, oh, damn, it didn't fix it. And then that one thing you forgot to check is what the problem is. Okay? So that's why we need to start this on paper. So if I know what I'm expecting to see and I go test it and I don't see what I'm expecting to see, do I have a problem? Yeah. Okay? That's the beautiful thing about being able to apply this. Okay? I remember one of the shops I worked at, I got made fun of a lot because I used to do stuff like this. Like, don't waste your time. You don't need that shit. Okay? I still fix those old farts cars because they can't fix them. Okay? But to this day, I still get shit talked to because I do all this stuff. Or they used to tell me, bring your little magic box. Let's see what's wrong with this car. What they were referring to was a oscilloscope. Bring your scope. Let's see what's wrong with it. Okay? So let's look at this one real quick. If I got a battery with 12 volts, I have a light bulb that has 4 ohms. I'm going to change that. It's not a light bulb. We're going to call this a fuel injector. My fuel injector has 4 ohms of resistance. How much amperage is that injector going to use when it turns on? 3 amps. If you go test that injector and it's pulling 5 amps, what's wrong? Did resistance go down? Would you guys consider that a short circuit? Yeah. Okay. Your diag's done at that point because you already confirmed. If current went up, it can't. The only way it can go up is if it has a short circuit. So the winding internally is damaged. Okay. And if this is a fuel injector, how can I test all the injectors out of one test point? I could pull a fuse. So if I go pull the fuse that feeds all 4, 5, 6, 8, 10, 12 injectors, I can put a loop on it, put my amp clamp around it. Now I can see all my injectors on one scope pattern. If I want to know which one's which, then I'll synchronize off of an injector and then follow my firing order from there. Then I'm going to know which injector is the one that's bad. Now I can sell that one injector or sell them all. I could do that with coils too. Okay? So as long as you're aware of what you're expecting to see, and then you go test it and it's not what you're expecting, do you know you got a problem? Yeah. Okay? Wattage. They're going to ask you about this. How do you calculate wattage? Amps times voltage. Okay? They're going to ask you that. Right? Now, it's about 700 and some change of watts equals 1 horsepower. So if you guys got like 1,000-watt microwave, little fucker's like 1.5 horsepower. All right? It's a little beefy bastard. Okay? So when you guys are heating up your lunch, just remember that. Okay? So power is equal to amps times what? Voltage. Okay? All right. So I was never good at math. I was always counting with my toes and stuff. So we're going to have some fun with this real quick. This is a series circuit. Okay? How many of you guys have ever solved for a series circuit? I'll be honest with you, in the field, I've never had to do this. Okay? But this is a good way for you guys to understand how this works. Okay? So we have one battery. We got one source of electron flow back to ground. I got two loads. One of them's 3 ohms. One of them's 9 ohms. Okay? In a series circuit, we have RT. So resistance adds for a total. What's my total resistance for this circuit? Based off of a 3 and a 9 ohm light bulb. 12 ohms? You guys agree? So if I have a 12-volt battery with 12 ohms of resistance, what's the current draw for this entire circuit? How many times is 12 going to 12? Once. So what's your current draw? 1. In a series circuit, current is the same everywhere. Doesn't matter. So if I test it here, what is it going to be? Over here? 1. Okay? Now, if I want to figure out the voltage, okay, I need to multiply amps and resistance. Is that true? So if I have 1 amp of current draw and a 3 ohm resistor, okay, what's going to be the voltage consumption for that load? 3. If I have 9 ohms of resistance and 1 amp, what's going to be my voltage consumption for that load? 9. For a total of 12. And you started with 12. Do you have a problem within that circuit? No. Okay? Does that make sense to everybody? All right? Sorry, I have a tickle in my throat. Okay. Just these are the rules for a series circuit. I already covered those. But the same. Resistance is RT, so you add those up for a total. Then after that, excuse me, damn it, you're going to figure out what the current is. Once you know the current, then you can figure out the voltage drop. Okay? All right, the next one would be a parallel circuit. These are a little bit different. So in a parallel circuit, voltage across each branch is equal. Okay? Total current in a parallel circuit equals the sum of the current flowing in each branch for the individual circuit, and the total resistance of the parallel decreases the more you add. Okay? Listen to that last one. The more branches you add, you start decreasing the amount of current. Interesting. What happens when, resistance begins to decrease? What happens when resistance goes down? Amperage goes up. Okay? So remember that analogy or that example I was giving you guys earlier where you have 3 shift solenoids, you add another load of some sort, you just decreased what? Resistance. So what went up? Current. So if you have a 10 amp circuit and you just added some more decrease of resistance, now you're going to flow more current. That's going to cause fuses to blow, circuits to overheat, modules to freak the fuck out, right? Okay, so all of that has a effect, okay? So we're going to analyze this one real quick. We got a battery, 12-volt battery. We got one load here, which has 2 volts, right? Then we have another load here, which has 6 volts, and then this one has 12. Okay, how are you going to solve for this? So on this one, if this is 2 ohms, right? And this is a 12-volt battery, how many amps of current are going to flow through this part of the circuit? 6, right? Okay. So this amp clamp is measuring 6. Is that accurate? Okay. This one has 6 ohms of resistance, right? And we have a 12-volt battery. How much are you going to draw on that circuit? 2 amps. Is that amp clamp correct? Okay. And this last one has 12 ohms of resistance with a 12-volt battery. How much are you going to draw on that one? Is that right? Okay. So now you have 6, 2, and 1. Is that 9? So if I have all 3 of these on at the same time, should I expect to see 9 amps here? Yeah, right? Okay. In most cases, are all the loads on a parallel circuit on at the same time? No. Okay. But if for some reason they were to turn on all at the same time, okay, your circuit was designed to sustain that many loads. Okay. So if this is a 9 amp circuit, it'd probably be rated for, you probably wouldn't want to do 10 because you'll, that a little bump, you'll blow it, right? Probably maybe 15, somewhere around there. Okay. But can you imagine this is on a car and all of a sudden somebody starts wiring in an amp, a light bar, a second light bar, okay? And it's running off of a circuit that was pre-designed for another amount of current. And when you turn all that shit on all at the same time, what's going to happen? Blow a fuse. Okay? By the way, I decided to use this amp clamp because this is one of my favorites. Okay, this is an ES688, pretty badass amp probe. This is a standalone, works very well. So if you're trying to find a parasitic draw, this thing works badass. Okay? All right. How many of you guys have ever heard of Kirchhoff's law of voltage drop? If you haven't, it's real simple. Whatever you start with, you finish with. Okay? And what we mean by that is if I'm going to do a voltage drop test from point A to point B, we're going to get 0.025. So that's 25 millivolts. Okay? From point B to C, that's 11.835 volts. From C to D, right there, we're looking at 25 millivolts. From D to E, so across the switch is 60 millivolts. E to F is 30 millivolts. And then G to H is 25 millivolts. If you add those up, what should your total be? 12. If they don't add up, you got a problem. Okay? So you got resistance somewhere. Right? Remember, is this light bulb on or off? On. How do you do a voltage drop test? In what condition must the circuit be? On. Loaded. Okay? If it's not on, you're wasting your time because it's going to pass. Okay? You need to load the circuit. All right? Okay. What are we measuring here across the battery? Voltage potential is 12.6 volts. Is that a good battery? Would you start testing that car if that car was in your shop? Yeah. Okay. Lower than that, don't waste your time. All right. Anybody need to use the restroom? Take a quick break, or you guys want to hammer it through? Hammer it through? All right. Okay. So when you guys are looking or taking your ASE exam, even if you're not taking ASE and you guys are reading a wiring diagram, what does it indicate when you see a box with these dashed lines around any component? That means it's part of a larger part of a diagram. Okay? So if I'm looking at it and I see these dashed lines, that means that this right here is just a small part of a larger diagram. Okay? So as you guys could see, just like with any conventional theory wiring diagram, where are my powers? At the top. Where are my grounds going to be? The bottom. What's going to be in the middle? Loads and componentry, right? Okay. Based off of that, we have a turn signal flasher, a hazard flasher, which then goes into a multifunction switch, which then gives me 2 lights or 2 loads, then goes back to ground, right? If I'm going to turn these lights on, where's my power feed coming from? top, are those fuses? Would you guys say that if you get a question that says that your turn signals are inoperative and one of the answers is a blown fuse, would that be a good idea? Yeah, because if we look at the diagram, that one fuse runs to your turn signal flasher, right? From there, where does it go? Multifunction switch, and then goes to your two lights, right? What if they give you a question that says that your turn signals, only your right one works, not your left? Could it still be the fuse?
No, because it's getting power.
If it was a fuse, both of them would be out. Okay, what if they tell you it's the ground? Could it be the ground? If it was the ground, wouldn't both of them be inoperative? Okay. What if they tell you it's the connection from the ground at the bottom of the light? Is that possible? Yeah. Okay. Yeah, it's in parallel, right? What we need to look at is, what are these both operating together or individually? Right? Or what do they have in common? Is the best thing to ask yourself. Does that make sense? Okay, they have power in common and ground in common. If this one was out or this one was out, they'd both be out. And if the answer or the question shows one out, not both, then it's not those two. Does that make sense? Okay. All right. I love this one. Okay. So this one looks to be complicated, but it's not. What do you have? You have 3 relays, right? Then we have a combination switch. And this switch, is this a power controlled or a ground controlled switch? Ground. Okay. That's something you always need to ask yourself. Is this component power controlled or ground controlled? Okay. Why do you need to know that? So you know how to trace it back. How does this thing work? Right? So we look at it, we got our power distribution here at the top with 3 fuses, right? Our fuse box then feeds one relay, which is here. What do I need on the control side of a relay for it to work? Power and ground or signal, okay? What 2 pins are those? 85 and 86, right? Okay, so 85 and 86 create a ground circuit on this coil side right here of the relay. That magnetism then closes the relay, right? So if we look at our relay, from there, we're going to have power coming down. Once this magnetizes, this closes. So now current flows through it, then turns on this magnet, and then this one closes, right? And then current leaves that way, but it also sends power this way. In order for this one to turn on, this needs to be close to the low position. Is it close to the low position? Yeah. So the moment that my first relay turns on, right, which means I need to turn on my combination switch to tail or headlights, right? When that happens, now I have ground coming up. I already have a power feed here. This magnetizes and closes. Now this sends power up this way. I have ground here. This magnetizes, closes, and now sends current out that way. Okay? So a relay is a shit. Because remember, a relay takes in low current to control a high current device, right? Look at a starter motor. How many amps can a starter draw during crank? V8 could pull about 180 amps. Right? So you're not going to run a wire for that. Can you imagine how thick that wire is going to be leaving your ignition switch? That costs money. Okay? Manufacturers make cars to make money. So they're not going to install this fat-ass wire leaving your ignition switch all the way to your starter. So what do? They use a small little gauge wire that goes from your switch, which sends low current to the coil side of the relay. Relay closes, then supplies power through high current from the battery, then starts a car. Your fuel pump's the same way. We use a relay for that. Okay? All right. If you guys don't know your pins by memory, take a picture of this. 85, 86 are usually the control side. Okay? From there, we have pin 30, which is usually going to be power feed, and then 87 is power out. Okay? If you're dealing with Asian cars, 85 is pin 1, 86 is pin 2, 30 is pin 3, and 87 is pin 5. So that's Honda, Toyota, that's what you'll be dealing with, okay? The other thing you guys might notice is notice how this one has a diode and then this one has a resistor. These are clamping diodes and clamping resistors. What we're doing is we're cutting off the voltage spike. Anytime we have a relay or a coil of some sort that turns off, there's always going to be a voltage spike, okay? So in order to avoid damage in the circuit, we use a diode or a resistor to then swallow up that voltage spike so it doesn't feed back into the computer, right? How do you think the computer would react if 100 volts from a fuel injector turning off back feeds into the PCM? PCM's going to go, right? Just fucking go berserk, okay? I've seen it happen with ignition coils. So if you have that much voltage back feeding into a module, it's going to fucking go crazy. Okay, that's when modules reset, and that's when customers complain of stuff like gauges, clusters dying, and then coming back to life, stuff like that. Okay? This one right here, I use this diagram in here to show you guys what are we using to control these two HID lights? A relay. Okay, what's controlling the relay? The power side or the ground side? It's ground control. Okay, and who controls the ground? Switch. We have a power feed coming from a fuse, then that supplies power to the coil side and actually the feed side of the relay. When this switch closes, then it grounds out the excuse me, the coil side, closes the relay. Now I have current flow through the relay to what? Your HID lights. Okay? How have we changed cars now? Are they still doing it this way, or do we do it different now? We do it different now. Okay? Cars now, your headlights are operated by your body control module. You got a computer doing it. Okay? Which is cool. Because when people replace their lights with shit they bought on Amazon or eBay, okay, then when they show up and half their interior stuff doesn't work, radio don't work, HVAC don't work, it's like, cool, you know, you just probably killed your BCM. Okay? Matter of fact, we had a Chevy Malibu that we diagnosed for a student. The concern on it was the car would go crazy, like crazy, crazy. Lights were flickering, lights were dimming, and all it was cheap LED headlights that they installed on the car. When we turned them off, the car went back to normal. Or all we did was unplug them, I'm sorry. Okay? And we narrowed it down to, I think it was a driver's side one that was humming. The passenger side one was humming, and we saw it on the scope capture. Once we unplugged it, it went back to normal. Okay? So no, look at this one here. Instead of having a switch, what's controlling this motor? PCM. Okay? So now the PCM is going to look for inputs, right? We're going to call that a radiator fan. How does the computer know when to turn on the radiator fan? It looks at the ECT, engine coolant temp, right? That's a thermistor. That thermistor creates a voltage drop based off of temperature, and that's how the PCM knows how hot or cold the engine is. So if that thermistor is telling the PCM that it's 240 degrees, the PCM is going to turn on the fan, right? Because it needs to bring down the temperature. Once that ECT starts reading a colder temperature that's predetermined by the manufacturer, what is it going to do to the fan? It's going to turn it off. So at that point, the PCM is going to cut the ground feed to this relay. So now the relay opens and turns off what? Fan motor. Does that make sense? Okay. How do you test for current? If you're going to test for current, there's two ways you could do it. You could do it this way, which I don't teach because it's harder, right? You got to take stuff apart. I don't like taking stuff apart. Okay, I'd rather use an amp probe because the amp probe is going to tell me how much current is flowing through the circuit anyway, and all I have to do is clamp it over the wire, right? If I have to do this, that means I have to open the circuit, then I got to put my meter in series, and my meter can only either sustain 10 amps or 20, depending on how expensive your meter is. Okay? And if you're not sure how much it could take, you'll find out real quick once you blow the fuse. Okay? That's a $20 fuse. It goes in your meter. Right? And we just found a couple during class that were blown. Okay? So, if you do that to your meter, Okay, you got to isolate the circuit. You got to open it up, all that fun stuff. Can you inadvertently fix the problem? Yeah. What if you have a small amount of corrosion on a connector, and when you open it up, you break that corrosion off? So when you're testing it, test fine. So now you put it back together, and now you can't duplicate the problem anymore. You just fixed it. Okay? Without knowing. Okay? Another thing I teach is this. If your customer comes in and says, after driving 30 minutes, I have this problem, it's electrical. How do you know that? Because what happens over time? What's a byproduct of current? Heat. Yeah. So imagine you're driving down the road and you have an electrical connector doing this shit. Right? It's loose. So over time, is it going to get hot? So once it gets hot, is that going to affect resistance? Yes. So resistance gets affected. Is the circuit going to have a problem? Yeah. Okay, so that's why we interview the customer. Car comes in, we always ask them, when does it happen? How long does it take to happen? 15, 20 minutes. Okay, cool. This shit's going to be like electrical. Right? Just think about it that way. Okay? This is why we also tell you guys, whenever a car comes in for a diag, you need to talk to the person who drives it. Not the wife, not the son, not the grandson, the granddaughter, whoever drives it. Because they can tell you how to duplicate that problem. Okay? Another thing we do is we go on a road test with them. So that way we can see how they drive the car for the problem to reoccur. Okay? And most shops don't do that. So now you're guessing at, hopefully that's the concern they have. Okay? I started doing that after I misdiagnosed the car. Car came in, customer's like, oh, it has a noise. I found another noise. I fixed another noise. Okay? And then after they picked it up, she came back. She's like, you didn't fix it. It's like, what do you mean? Right? We go on a road test, like, oh, that noise. Like, fuck. Right? Okay? So.
You ever had it when they bring it to you, stops making the noise?
Yeah, all the time. Yeah. White coat syndrome. The car gets scared, like, oh, shit, I'm at the shop. Yeah. And that's why we go road test it with them. If they can't make the problem reoccur, then at that point, it's like, I'm not making this shit up. Like, if you couldn't do it, how do you expect me to do it? Right? Okay? Plus, how many of you guys do this to make money? If you don't, you're in the wrong business, right? When you go on a road test with them, you also call out shit you hear, see, right? You're going down the road, they hit a bump, and you hear a ball joint pop, call that out. Okay, you heard that? And then shut up. Okay? That's it. Just call it out and shut up. It serves two purposes. One, when they get back to the shop, there's a higher likelihood of them telling the service advisor, he called something out. Can you guys check that? Absolutely. That's another line item. Okay, now I'm going to charge you to check that. If they decline that, document it. Why? Because when they pick it up and they hit the railroad tracks and they hear that pop and they bust a U-turn back to you and tell you, since you did my oil change, this shit's popping, it's like, Remember we went on a road test? Remember we documented this? And you said no? You want to fix that now, or do you want to keep playing games? Okay? Huh? Never. Never. Yeah. Okay? So imagine you hear that pop and you're like, oh, I think that's a strut. They're sold on that strut. So if they tell you, go ahead and check it, and you rack it, you find out it's a ball joint, you call them and tell them, oh, it needs a ball joint. No, I don't. Your mechanic said it was a strut. And you're not going to get them out of there. Okay? They're sold on it's a strut. And they're going to go on YouTube, Google, ask Jeeves or whatever the fuck they could find to make you look bad.
Or they try to go somewhere else and try to replace their struts.
Yeah. Yeah. Or they're going to find some mechanic on OfferUp that's charging $45 an hour that's going to change the struts for him and then tell them that you're a line psycho. You know what? Okay? They're just trying to rip you off. Blah, blah, blah. Okay? So that's why you call it out and then shut up. Okay? It works about 90% of the time. All right. So one of the ways that we can figure out if we have an electrical problem is to first do the math and predict what we're going to be expecting, just like we were talking about earlier, right? So this right here is our test light. How many of you guys take the time to know how much current your test light draws? Okay. Ours draws 226 milliamps. Okay. Our light bulb that we use to load circuits, the low side is 500 and something milliamps, and then the high side is 2.1 amps. Okay, we also use a sealed beam for fuel pumps. If we stack low and high together, it's 7.8 amps. Why do we need to know that? Because if you're going to substitute or plug something into a circuit and you don't know how much current that circuit can sustain, you could just buy yourself a computer. Okay? So now that I know this, and by the way, I got this at Harbor Freight. So if you guys buy one at Harbor Freight, it's roughly about the same amperage. Okay? So this one draws 226 milliamps. Can I put it in a circuit that draws 120? Yeah. But I can't put it on anything that's above that. Okay? So why? Because at this point, we could cause a problem. Okay? So make sure that you guys are testing out your equipment before you guys actually put it in. And I just caught myself. If it's lower than that, we got a problem. It has to be higher than that. So if the circuit you're testing draws 500 milliamps, you can use this light. But if it's a 120 milliamp circuit, you cannot use this light because you're going to burn that circuit. Okay, you guys ever heard somebody tell you you never use a test light on a computer-controlled circuit? Okay, I use them all the time.
Just as long as you know how much.
But I know how much it's going to draw. Okay? Me and Jose fixed a BMW that came in with a fried DME. I went to the dealer sold him a fuse box. Okay, all it was coil cylinder 3 burned out. The coil shorted, took out the PCM. Okay, you know how we figured it out? With a light bulb. All we did was plug in the light bulb into the circuit as if it was a coil, because it's an electronic component. It's not like the computer's going to be like, oh, shit, that's not a coil. I'm not going to light that up. Right? It's electrical. It doesn't know. So we put a light bulb on it. Key on, engine off, the light was on. That's not normal. That would mean that your ignition coil, key on, engine off, is firing. Okay? So then we ran the car with the car running. It was still on. Okay? And it wasn't pulsing. So we're like, all right, cool. Yeah, it's just done. It's a goner. So we recommended a DME and a coil. Put it on, take care of the problem. It's BMW, but so you know that's leaking oil and all kinds of other shit. But that took care of the issue. And how did we figure it out? It was using a light bulb. Okay? If you guys spend the money and you buy yourself a power probe, know how to use it. Okay? Do this. Read the manual. Right? The power probe has a lot of good features, but it can also blow some shit up. Okay? Look what I put on here. If you ever use a test light on a safety restraint system, you're going to pop the airbag. Okay? Any resistance on that circuit, that's just going to pop. All right? So be careful with that. Okay? And the reason why we mark them is because we use them to substitute loads. It's much easier for me to see the brightness of a bulb than it is to look at a diagram or a waveform, right? If my bulb is bright, is that circuit okay? Yeah. If it's dim, is it okay? No. How many of you guys take the time to load a circuit when you change a fuel pump? Okay? That hasn't happened to you yet. How many of you guys have replaced the same fuel pump on the same car multiple times? That's when I figured out that I need to start load testing fuel pump circuits. Okay?
The Chevy. Those are excluded.
Except Chevy, right? But how do you prevent that? You got to keep fuel in the tank. Okay? So you know what me and Jose start doing when we get multiple failures on the same car? We talk to the customer. But we don't ask them, do you run your tank low? Because they're always going to say no. Okay? So it's the way you ask, right? We'll go up to a customer and tell them, hey, if your fuel light comes on, do you know how many miles you could drive before it runs out of gas? Oh, about 35 miles. Huh, fucker. Right? So at that point, what did they just tell you? I run this shit low. Okay? So then when we warranty it out, we document that. Then we talk to them about it. You know, you just told me that you run your car with no fuel in it, right? So that's why your fuel pump keeps going out. This is the last one I could do. Okay? So you do that. All right? But obviously we load test the circuit because we want to make sure that circuit can sustain that load, right? And we use a sealed beam bulb for that. Got that from AutoZone, got the connector for it, put some stackable ends on it, works like a charm. All right, so if you get a diagram like this one, it shows 12.5 volts and you're on the negative side to the negative side. What's wrong with this circuit? Now remember, you got 2 minutes per question on an ASE test to figure it out. Put the music. Do, 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 do. So look at your circuit. We got a fuse. Did you say the computer? Sell them a computer. Fuck it. All right, so we got a fuse here, and then we got a switch. What position are you switching? Close. Do you have current flow? Yeah. Okay. Can you confirm you have current flow? Look at your meter. What's your meter showing? 12.5. So that means that from the negative side, the potential difference between negative side of the battery to what should be the negative side of the light bulb is 12.5 volts. That's telling me that bulb is not on. That's telling me I'm missing a ground. Do you guys see why I'm calling it a bad ground? Damn. Even the board wanted to get in. All right. So if we look at it here, I'm on the ground side, ground to ground. So that voltage drop should be near zero. Isn't that true? I'm seeing source voltage. If I'm seeing source voltage, that means that it's traveling through the bulb. So the bulb's not open, and it's coming out the other side of the bulb. If I had ground here with this switch closed the way it is, this light bulb should be on. Isn't that true? Because it's not on, it's missing one of two things, power or ground, right? Your voltmeter is showing you have the potential to work, but it's not working. So what's the only obvious thing that might be missing here? Ground. Okay, you guys see how we came across that? Yeah? Okay. All right, so this is one that we did here in class, and my student here is going on the post to the terminal, and that's how much voltage we have on the ground side. That's post to terminal. That was a good fix, by the way. Okay. So what's wrong with it? It's a huge voltage drop. Okay. And my student's watching. She knows who she is, right? Jose knows who she is. That's why he's laughing. Yoshi. All right. So if we look at this one right here, okay, these are common tests that most shops won't run. And if you would have looked at that electrical connection, it looked okay. In my eyes, they didn't, but for the average tech, it would be like, yeah, that shit looks fine. Okay. And that was the whole problem. Okay, the initial concerns, you turn on turn signals and stuff, the car would go haywire. Dash would turn off. Okay. And then when we pulled it into the shop, the lights were flickering. Okay. Especially if you stepped on like the brakes, and it was raining that day. So wipers were on and it would get worse. Okay. That's because we didn't have a good ground. All right. And all we did, well, actually, all they did was fix that ground. They cut the wire, added a new end. We cleaned it off, added some Stabilin 22, put it all back together. Okay. Could you imagine that ending up at the wrong shop? What they would have thrown at it? Body control module. Right? I would have seen a couple modules going at this shit. Yeah, and then if she only had one key when they were doing computers, then they'd sell another key for the programming, right? So that shit would have got expensive real quick. And then they'd be like, damn, I didn't fix it. Okay. Then they would ship it off to the dealer, where they would probably throw more parts at it before they call engineering. Okay. So you see why people do not wake up excited to go get their cars worked on? For that kind of problem. Okay. All right. You guys are going to get a question on the ASE exam about CAN bus. What two pins does CAN bus work on a car? You guys don't know the pins by memory? Jesus. Okay. Chassis ground is 4. Sensor ground or PCM ground is 5. Pin 16 is unswitched battery power. Okay. Pin 2 is GM. Okay. VPW. Pin 2 and 10 is Ford PWM. 6 and 14 is CAN. 7 and 15 is ISO 9141-2 or keyword protocol. Okay, so when you're talking about CAN is always on pin 6 and 14. Okay, and you need to remember this for testing and for the shop. You're working on a CAN car and you have a communication fault, a U code, where are you going to go look for it? Pin 6 and 14. Okay, what we're showing you guys here is CAN bus at idle, okay, or in a recessive state is at 2.5 volts. When CAN begins to communicate, CAN high goes up 1 volt, CAN low goes down 1 volt. So when CAN begins to talk or any module begins to communicate, send data packets, okay, CAN high goes from 2.5 to 3.5 volts. CAN low goes from 2.5 to 1.5 volts. Okay. This is that's all you need to remember for the ASE. Right? When you're in the field, it's a whole different ballgame because you're going to need a scope. You're going to need a lot of patience to then start figuring out which module is the one that's not talking. Okay. Pin 6 and 14. Okay. So recessive state is when it's at 2.5, a dominant state, down 1, up 1. Okay, that's the best way to remember it. When it's talking, up 1, down 1. Okay, that's it. That's all you got to remember, right? That was a good final, by the way. Okay, if you guys are looking at a wiring diagram, where are you going to find the powers on any automotive wiring diagram? The top. Okay, and if you ever have a hard time remembering that, just remember when you stand up, what are you standing on? The ground. So where's the ground going to be on a wiring diagram? At the bottom. Okay. If we have a dot like we do here with S101, is that a splice? Do those wires interconnect? Based off of what you guys already know, where is splice 101 located? In the engine compartment. Okay. Remember, you guys need to remember that. All right. Any questions on this before we move on from here? Okay. On the color code, you guys just need to be kind of aware. BLU is for blue, BLK is for black. Okay, the first color you see is going to be the whole solid wire. Second color is going to be a stripe. Okay, so if you see BL and then RD, that's a blue wire with a red stripe. Don't go looking for a red wire with a blue stripe because you'll find it. It's just not going to be the right wire. Okay, so you fuck up on the wire, excuse my French, you're going to burn some shit out or you're going to sell a part that was actually good because you tested the wrong circuit. Okay? So you got to be careful with that, especially if you're going to end up looking at a wiring diagram or testing directly at the PCM. Okay? We had that. We had our students do that. Jose was here for that. We had them diagnose a car from the PCM. So we were testing circuits from the PCM, not at the sensor. Okay, it's usually a better way to do it because now you're going to be testing circuit integrity and all that fun stuff, but sometimes it's hard to get to. Okay, but if whenever possible, go to the PCM, the Ranger, and the Bronco. Okay. They got fast by the end of the last die. They were done like in 10 minutes for a no crank, no start. All they did, yeah, the Suburban. Yeah. Okay. All right. So whenever we're looking at a wiring diagram, simply just pay attention to what color it is. Like this one right here. This is from Mitchell. That's red. RD would also be red. Just depends on who wrote the diagram. Okay. Oops. So if you guys see a letter C in front of it, that's how you're going to know it's a connector. If you see an S, that would be a splice. This is G307. Where's that going to be? Passenger compartment. And it's a ground. Okay. This one right here, it's under a center console. This would be a good one where this body control module, let's say that the customer comes in and says, I'm having problems with a lot of the componentry that's controlled by the BCM. Okay. Exactly. Okay. We've seen that quite a bit. Coffee, water. Okay. So all of that, people don't, they're just, oh shit, I dropped some water. What's under the dash, right? What's under the console? Okay. Crazy part is sometimes it's not instantaneous. It takes a while. Okay, once that soda evaporates and then leaves all the sticky residue, then that's when current starts jumping from one wire to the other. That's when you start getting some weird freaking problems. Yeah. No, yeah. I had a Mercedes one time that went into like limp mode. So the car thought it was being stolen because they spilled water on the center console. It wouldn't. You couldn't get it out of drive. You couldn't unlock it. The alarm was just going off. It was a mess because they dropped water in the center console. Okay.
And the customer didn't say that, so you gotta.
Yeah, they never freaking tell you. Yeah, customers are sneaky bastards. In their mind is if I tell him, I want to see how good he is. I'm not gonna tell him shit. So, yeah, that's one of the reasons why the way we do things. The service advisor, Des, our service advisor, does all the talking to the customer. We created an interview sheet where a customer fills that out, and then we take a picture of that and put it on our RO. So this way, when we're in the back, we get to see that interview sheet. It helps us a lot better. And then it's not a guy asking that information, it's a girl asking that information, right? So typically, if it's a guy talking to her, he's more open to share information. If it's a girl, she feels more comfortable because she's a girl, so it's easier, right? I've been to shops where there's a guy behind the counter, and you see a guy walking in with a guy behind the counter. First thing, we call it the ram effect, right? They're both chest out, kind of like ready to fucking rock and roll. But in reality, that's just creates headbutting. Okay, so if you guys own a shop, throw a girl in the front. It's much better. Okay, you're gonna get a question that looks something like this. How many of you guys have ever tested a rear defroster or a defogger? Okay, we've only had to test a couple after they got replaced and then they were not operational. Okay, so one of the ways you can test this is using a voltmeter. You're usually going to have positive side on one, ground on the other, and current's going to flow through across it. Okay, what you want to do is using your voltmeter, you can kind of go moving it across, making sure you have voltage all the way across. Okay, if the point where you get to where you don't have voltage, you know you have an open circuit. Okay, so then at that point, how do you repair that? You're replacing the whole window. Okay, so the whole rear window needs to get replaced. So last one the guys worked on was one that got replaced by a really big company that replaces windows, and they didn't plug it in. I don't want to say the name, but yeah, they didn't plug it in. Okay, we tested it and there was power and everything going in. We just plugged it in and it worked. So then we just charged the lady for the diag and shipped it on its way. Okay, so it's not always going to be something complicated. All right. Okay, this one comes directly from ASE. I'm not going to tell you that this is on the ASE test that you might be taking, but this is something what you guys would be seeing when it comes to wiring diagrams. So if we look at this diagram, let's say they give you a question that says that the cooling fan is inoperative, right? Where's your ground coming from? Is that independent, or does that come from a relay, or is that computer controlled? For the fan motor. It's independent, it's by itself, right? How do we control this fan? Power or ground control? Okay, power. Where's the power coming from? Fan relay, right? So if we look at this, we have a fuse up here. This fuse sends power down to the relay, right? And then we also have this ground control to the relay. And then this one has power coming up from this particular fuse. So at this point, right here, this is hot at all times. So would you guys agree that we should always have power at pin C of the relay? Okay. Then when this ground from the PCM closes, now this relay magnetizes, closes here, and now current comes out of pin D. Is that true? Okay. So what you're going to be looking for is an answer that only affects that fan relay. Because the question they're telling you is only for what? The fan. Okay. Don't start thinking, well, what if it's the AC relay or maybe the HVAC module is bad? No, you're overthinking it. Only diag what's in front of you. Whatever they put on paper is what you're going to be looking at, right? Okay. Here's another one. What's pin 6 and 14 of the DLC?
6 and 14?
What's 6 and 14 of the DLC? Can. There you go. All right. So if I go across pin 6 and 14 with the ohm meter, how many ohms of resistance should I see? There's two 120 ohm resistors in parallel. What do you do with two parallel resistors? You cut them in half. So it would be 60 ohms, okay? I need to say this before somebody online chews me out. This is only if there's no gateway module. If you have a gateway module, that doesn't exist, okay? All right? And ASE hasn't got to gateway modules yet. So no gateway module, go across 6 and 14, 60 ohms. Typically, it's about 58, okay? Now, if you guys look at this diagram, we have a 120 ohm resistor that's located inside of what? The cluster, okay? Where's the other one? It's usually in the PCM, according to ASE, okay? So if you get a question that says that you go across pins 6 and 14 of the DLC and you're seeing 120 ohms, what is that telling you? It should be 60, but you're seeing 120. Did you lose one of those resistors? Okay, so if they give you an answer that says the instrument cluster, would that be a good answer? Yeah. Okay. Now, in real life, some GMs have one of the terminating resistors at the breakout connector for the tow hitch, for the trailer connector. Why, I have no fucking clue, but it's there. Okay. So most of the time, in order for you to find where this terminating resistor is going to be, you got to look up the manufacturer diagram. Mitchell doesn't have them. There's all data. Where we found them before is Motologic and Identifix. Okay. Or what you're going to do is you're going to pay for the subscription for the manufacturer and then get the diagram off of there. Okay. Somebody making fun of me online. See? You see? I knew it was coming. Okay. Yeah, I forgot I was live. Yeah. Yeah. They were like, come on, come on, come on. Right? Jeez. Like he missed it. No, there you go. See, that's why I got Jose checking it out in the back, though. Got this. All right. So again, this comes directly from ASE. This is the composite vehicle. So after you guys pass your A6 and A8, you're gonna take the L1. Okay, I'm not telling you you might. You're gonna take it. Okay, because if you have A6, A8, L1, you're valuable just with those three. Okay, so this comes from the composite vehicle. Notice how we have one 120 ohm resistor located inside the PCM, and where's the other one? Cluster. Okay, so if you guys, well, I know you guys haven't taken it. So the L1 composite vehicle is basically like Mitchell for the car you're working on during that whole 75 question test. Okay, so you need to know how that car is operating, systems, all that fun stuff, and that's where you find it in the composite vehicle. Okay, so I stole this from the composite vehicle to show it to you guys. So if you were to get a question while taking the L1 about showing 120 ohms of resistance, that means either PCM's gone or the cluster's gone. Does that make sense? Okay, because those two are in parallel. So we got two of them, that should be 60 ohms, right? Okay, so let's do a quick review here. So if you guys are using your voltmeter and you're on the negative side of the battery and then on the negative side of the light bulb and you're seeing 12.6 volts, what's wrong with that circuit? Quickly. Ground issue? Why is it not the light bulb? It went through. What if that was an injector? Same thing. Okay, that's usually how I verify injectors. Make sure they're not open, right? If I go on one side of the injector, I got 12 volts. I go to the other side and I still got 12 volts. Key on, engine off. Is the injector okay? No. In theory, the coil's fine, right? Then I need to load test it using current. Does that make sense? But if it went through, it's not open. Is it shorted? I don't know, right? But I can tell you it's not open, right? So that injector is not open electrically. Does that make sense? Okay, same thing there. If they went through that light bulb, is that light bulb burned out? No, you can replace them all the ones you want. It's still not going to work. Where's your problem? Ground. Okay, can I run a supplemental ground and see if it turns on? What if I ground it and it turns on? Did you just figure out what's wrong with it? Yeah. Sell them a power probe, right? Just tell the customer, hey, look, when it doesn't work, just hit this button and it'll fucking work, right? You guys know Harbor Freight sells power probes though?
Really?
Yeah. That's amazing.
Really cheap?
No, it's about the same. I was pretty excited though. That's gonna give us more work. When all these people get their 20% coupon, go buy one and blow some shit up. It's great. All right, so we got another one here. Okay, this one has a relay, and then we got 2 meters. Okay, meter A is before the relay, showing 12.5. Meter B is after the relay, still showing 12.5. What is that telling you about the relay? What's the condition of that relay, on or off? So the relay, if I'm seeing source voltage before the relay and source voltage after the relay, isn't it true that that relay is on? Yeah. Okay.
Not it would only show on one end, right?
Right. So if this relay was not on, I'd have 12 volts here, but I'd see 0 here. Does that make sense? Okay. So if they were to give you any question on this, with this being open, is that true? No, because that relay is closed and there's current flowing through it, right? Yeah. And then we could confirm that because what's wrong with this light bulb? It's on. That means there's current flow. Okay. Here's another one. Okay. We call this pinpoint testing, which in the field, this is what you guys should be doing to find electrical problems, right? At what point are we testing and what should I expect to see at that particular point, right? So we look at the first one, after the ignition switch, I got 12.6 volts. Is that okay? So that means my switch is on because it's flowing voltage through it, right? Then I get to my motor switch. Before the motor switch, I have 12.6 volts. So that means from the switch to the motor switch, I'm okay, right? From there, I got another voltmeter in volts, and I'm going to cross the actual load. Wouldn't it be true that this motor has to use up all 12.6 volts? How much is it using? 6. Where's the rest of it going? So what did I tell you guys if we have unused voltage on the last load? Got a ground problem. Resistance, right? Go check that ground. Did it just come from a body shop? Yeah. All right. Cool. Let's go find where they fucked up. Okay. Is it on plastic? No.
Put it over the paint. They paint under it.
They paint over them. We fixed a lot of painted over grounds. Or they just don't put it on. They're like, ground strap, fuck it, we don't need it. Yeah. Yeah. Well, I mean, I shared a story with you guys on a Mercedes iDiag. Okay. Check this one out. Mercedes drives into a transmission shop, right? Okay. It drove in. They do the transmission and then they push it over to the shop I was working at because it wouldn't start anymore. Good one, huh? Okay. They forgot a ground strap. So when I racked the car, the first thing I noticed, I was like, there's a hole there and there's an eyelet where there should be a ground strap, right? So all I did was get a wire, clamped it, lowered the car, got my big ass in the car, and I cranked it and it started. Okay. So then at that point, I just waited about an hour or so, called the shop, told them they had an open circuit, that they messed up the wiring loom. We charged them a couple $100, ordered a new braided ground strap, put it back on, shipped it. It's not my fault they're retards, right? So you got to charge for all of that. Okay. But you always ask, like, what did you do to it? Okay. You guys ever seen a car go into a stereo shop and then get towed out? Yeah, those are fun. Okay, I got to work on one of those. These retards connected the remote from the amplifier to the CAN bus.
Yeah, all the time.
It was an avalanche. So it wouldn't shift over first gear. It wouldn't go over 10 miles an hour. Okay, and it was all because they saw voltage there, so like, all right, cool, we'll clamp it on there. So that's why you got to ask those kinds of questions. Okay. So here we're looking at another one. This is a series circuit. Is this normal where we have voltage drop across one load, another voltage drop across this one, and then another voltage drop across this one? And if you add them up, that's 4, 8, 12. What's your source voltage? 12. Is that normal? Yeah. Okay. So let's look at this one. So this one here, we got a fuse, a relay, a switch, and 2 horns. Okay, so let's look at this first meter, 12 volts. We're on the base of the relay to ground. Is this relay good? Because I have 12 volts on the output side of the control side of the relay. Yeah, right? Because if this relay was opened on the control side, I wouldn't have 12 volts at pin 2. But I have 12 volts at pin 2. So that means current's flowing from pin 1 through pin 2. What is it missing for it to turn on? Ground, right? What controls my ground? The horn switch, your clock spring, right? Or depending who worked on it, maybe a toggle switch. I don't know. Okay, from there, if we go to pin 3 is showing how many volts? Is that relay on or off? Off, right? The moment that I hit this horn switch, that's going to supply ground, magnetize the relay. Then now I'm going to have power coming in through pin 5, out through pin 3, and what's going to happen to my horns? They're going to work. Okay? What about this one? I got 0 volts going across the relay from the input side to the output side of the control side. What is that telling you about this fuse? It's open. So if this was a diagram on the ASE exam and they show you that exact thing, is it bad ground? No, it's a fuse. And we could confirm it's a fuse because we're going across the relay and we have 0 volts. So that means there's no what? There's no power feed. That makes sense? Okay, my job as a tech, if this was a real car, it's not just to replace the fuse. I need to figure out what the hell drew enough current to blow the fuse. Okay? And if I look at this diagram, what's the only thing on the diagram that could blow the fuse? The horn. Was it in an accident? Right? Okay? Those are the kinds of questions we gotta ask. Oh man. I'm telling you guys, we see all kinds of crazy shit. Okay, so look at this one. We got a voltmeter here showing 270 millivolts from the positive side to the input side of the light bulb. On the output side, how much voltage do you have? 2.6 volts. What's wrong with that ground? So your power feed again from positive to positive is 270 millivolts. From ground to ground, 2.6 volts. What's wrong with it? I got excessive voltage drop. Could it be corrosion? Bad connection? Body shop painted over it? They put it on plastic? Right? Okay? All right. So right here, we're testing the resistance of this injector. If it has 11 ohms of resistance and you have 12 volts going to it, how much current is it going to draw? A little bit over 1 amp. True? Yeah. So if you know that and you go test it and it's drawing 2 amps, what's wrong? Is the injector bad? Yeah, resistance went down. That makes sense? Okay. So on this one, we got 2 lights here. We got a ground that splices to both of them, and then we got power feeds to both. I'm on the power side and the ground side, and I got 8.3 volts. Do you have a problem there? Yes. Is it the ground or the power? So shouldn't we have 12 volts here? But we only have 8. Would you guys agree that it'd be better to test the other one too, just to confirm? Yeah. So if you test the other one and you're getting this, what is that telling you?
Was the other one tested after the light? Oh,
so this one's before the load,
and
to ground, and then this one's after. So after the load, you got 10 volts from here to here. What is that confirming for you? Where, on what side is the voltage drop? Power or ground? Ground. Okay, so that would be a bad ground. right? Because now what you did from here, you went on the feed side to ground, and it was 8. And then here you went ground to ground, and you got 10. So now you could really condemn that ground. Does that make sense? Okay. All right. Okay. You guys ready to do some sample questions? All right. So here's how I'm going to pressure you guys. We're going to put a timer. You got 2 minutes per question to answer it. Okay. All of these questions, I didn't make them up. These came from ASE. They loaned me these questions. Okay. You might see something similar to it, but not these exact questions. Okay. So you guys ready? Go. So in charging system shown with the engine running, the digital multimeter will display. So if we look at this diagram here, here's my multimeter, here's my alternator. So I'm connected on the output side of the alternator to the positive side of the battery. Are we doing a charging output voltage, regulator operating voltage, charging circuit voltage drop, or ignition switch voltage drop? C, A, okay. Why is it not A? If it was A, wouldn't we be power to ground? Remember, power to power is what? Voltage drop. If I'm ground to ground, voltage drop, right? Power to power, voltage drop. If I'm power to ground, potential. Okay, you got to remember that one, right? Good shit. You guys answered that in 30 seconds. Important part, huh? Get it. Get it. Just all right, ready? Let's go. Next one. The oil pressure light stays on whenever the engine is running. Oil pressure has been checked and is within spec. Technician A says that the ground circuit between the indicator light and the pressure switch could be the cause. Technician B says that an open in the pressure switch could be the cause. Who is correct? B? Nice. 20 seconds. B? B, B, B? So technician A says that the ground circuit between the indicator light and the pressure switch could be the cause. Okay. On dash indicator lights, they have a constant power feed. How do we turn them on? Ground. So it's ground activated. So, and they told you in the question that they already checked oil pressure and it was within spec. Right? Okay. Hey, the theory don't work. You guys missed the key word here. Tech B is what? If it's open, do we have flow of current? If there's no flow, would a light bulb turn on? No. See how you guys missed that key word? Okay. All right. I was just testing, you know. I was just playing. All right. Let's go to the next one. Okay, ready? Passenger side power window operates properly when using the passenger side control switch, but the window will not operate down position only when using the driver master switch control. Which of these could be the cause? You read that wrong. Did I read that wrong? You said, but the window will operate in the down position only when using the driver side master control switch. So is it a pinched wire from the passenger side control switch to the window motor, an open wire to the driver side window motor, grounded power wire to the power window control or circuit breaker, or an open circuit in the driver side master control switch? D? D? Look at you. In 54 seconds, you guys got that one. You gotta go quick. It's like a band-aid. Just rip that shit off. All right. You guys ready? Go. So the brake lights are not working on a vehicle with a circuit shown and the brake pedal pressed. Technician observes the DMM readings Which of these could be the cause? High resistance at W, open circuit at X, short to ground at Y, open circuit at Z. Oh, that's an easy one. I heard B. B. Everybody agree with B? What kind of test are you doing across that switch? We're going to cross it, right? So that's a voltage drop test. Am I seeing source voltage? Yeah. So that means I have ground on one side, power on the other. So I'm reading potential, right? Okay, so what is that indicating to you? Open switch, right? If there was current flow there, it should be under 300 millivolts, right? 0.3. Does that make sense? Okay. You're going to get a lot of those. All right, ready? Go. So technician A says a fusible link in the alternator charging circuit is replaced with system-size wire. The circuit will be unprotected. Technician B says if a fusible link in the alternator charging circuit is replaced with system-sized wire, the battery will overcharge. Who is correct? Which one would you not let work on any electrical vehicles? Both A and B? A? Okay. A? Okay. Anytime you replace a fusible link, which is older technology, it's two. Just bypass it. Fuck it. It's two American wire gauge smaller than the circuit it's protecting. Okay, so A was right. So this one you guys took 55 seconds. That's about the same. Yeah. You guys are doing good.
As long as we get them right, the time's not the problem.
Go. Starter solenoid clicks, but the starter does not crank the engine. Technician A says a burned solenoid contact could be the cause. Technician B says that a poor battery cable connection could be the cause. Okay. Remember we learned about scopes, though, when it comes to starter contacts. A, B, C, or D. Pick your poison. C? Okay. So we have one C. What else? B. And the answer is, if we have bad solenoid contacts, right? Remember, when we looked at the oscilloscope, when the solenoid contact closes, it's going to slide to the back. Now, current's going to transfer through those contact points back into the motor, right? So those contacts are burnt. What's going to happen? It's not going to close. There's going to be a VD, voltage drop there, right? So then that's going to cause the vehicle to click but not crank, okay? Then B, if I have a bad battery connection, is that going to affect the way the vehicle starts? Yeah. Then that's when we do a voltage drop test, right? Or sell them a battery starter, charging system, and everything just to kind of rule some shit out, right? Like most shops do.
Would that be considered a dwell time too, or that would be?
That would be the ignition coil. So remember dwell time, not dwell time, the solenoid. Remember when we did the current clamp on the battery while starting it, and then we had the in rise in current, and then it did this and then jumped up, and then we had that. This little hump right here, that would be the solenoid contacts. So remember I told you guys if it was hashy, then that was a jumping or bouncing contact. But we were seeing them all nice and round, except for one of them. What was it? The Suburban that had that huge spike on the solenoid. Remember that one? So that's what we were looking at. Okay. So next one. Ready? Go. So the horns in the circuit shown operate only when a jumper wire is connected between terminals 30 and 87 of the horn relay. Technician A says that the failed horn relay could be the cause. Technician B says that a short to ground in the circuit between the horn relay and the horn switch could be the cause. Okay, pick out your key terms here because that's going to lead you in the right direction. So if we look at the relay, 30 is your power in, 87 is your power out. They put a little jumper wire across it. We have action, right? Okay, so that means that the circuit's intact, in my opinion. So Tech A says it's a failed horn relay. Okay. A? I heard A. Okay. If it was a short to ground, it'd be honking all fucking day. Right? Because it'd be activated. Right? So that's why I said keywords. Short to ground here, okay, would make this thing on the whole time, so it'd always be honking. And they're telling you that they have to use a jumper wire for it to honk. So what's the only plausible cause here? Bad relay. Okay? We're bypassing the relay, exactly. Okay, next one. Which of these digital multimeter readings indicate current flow of 3 amps in a circuit? Do, 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 do. They didn't update. They didn't get an auto ranging meter. Like a cheap ass tech. D, okay. C, okay. C, okay. So remember, for every 1,000 milliamps, it's 1 amp, right? So if we got 3 amps, it's 3,000 milliamps. And yes, he needs a new meter. If you have to do that kind of calculation, you need a meter. Okay? You need a Fluke 88, version 5. All right. Go. Any of these would cause high starter current. Keyword, except. Okay? So these are usually going to kick your ass if you miss except. Horn starter bushing, failed starter relay, grounded field coil, or a seized AC compressor. This is an easy one. Ready? Not yet. You guys tell me when you're ready. A? A? If I have a bad starter relay, is that shit going to crank? What's the key word there? Except. Right? If I have a bad starter bushing, it's going to draw more current. If I have a grounded field coil, it's going to draw more current. If the AC compressor is seized, it's going to draw a shitload of current. But if I have a bad starter relay, it won't even crank. Does that make sense? Okay. You got to read through them. Keywords. Okay. Except. So when it says except, the only one that stands out here is what? Bad relay. If the relay doesn't work, that shit won't crank. If it doesn't crank, how the hell am I going to test it? All right, guys, and that's it. Okay?
Based on those questions, it doesn't seem too bad.
It's not hard. Okay? It's not hard. It's not hard. All right? Okay, I recertified it 4.5 years ago, and I missed the perfect score by 1 question. It's not hard. Okay. What makes it hard? We do. Don't overthink it.
Are they gonna ask a lot of questions regarding like the pins for relay?
No.
What about for home block?
Like calculating it, like one or two. Yeah. On the if they do give you a relay question, it's gonna be a picture, so you'll see the pins. So you don't yeah, you don't need to remember them.
They won't snake you with the out fucking going. They will be this one. It's not
No, no, that's my kind of test. No, that
So the outgoing is
yeah.
7.
So if I got a short to ground on pin 85 of the relay, right? No, they're not gonna do that. It's mostly diagrams, a lot of voltage drop. Okay, and the one thing I'll tell you guys is this: you read your question, then you read your 4 answers, and make those answers fit your question. Right? Right off the bat, there's gonna be 2 that you can kick right out of the way. Right? Then work on those last 2. If after about a minute or so you can't figure it out, there's a button there that you can flag it. Flag it. Move on. Don't waste your energy on that one question. Okay? Here's why. I write a lot of tests. Sooner or later, you're going to run into a question that answers that one. Okay? So just keep going through your tests. Right? And then you'll be like, oh, shit, I remember that one. You already flagged it. That's fine. Keep going. When you get to the end, go back and answer the ones you flagged. Once you answer those, finish your test. You're done. Don't go back and, well, let me read. No. Fuck no. Okay? Ask Jose. He's been there. I've been there. Okay? That's why I'm telling you this. Do not. Yeah, I failed test by one question. And then it's like, damn, I went back and changed one question. So it could have been it. Right? So don't do that. Right? Keep in mind when you guys go take the ASE exam, they treat you like a prisoner. You're going to show up. Here's how I'm going to recommend you go. Basketball shorts and a t-shirt. Go comfortable. It's going to be cold as shit in there. Okay, so if you get cold really fast, dress warm. The reason why I'm telling you shorts, because if you're wearing pants, you got to raise your pant legs. They're going to check your pant legs. Okay, they're going to use a metal detector to make sure you don't have anything. I wear glasses. I have to take them off. They check my glasses to make sure there's no writing in them. Okay, no jewelry, no watches, nothing. Okay, so it's worse than the smog test. No, smog test, they didn't give a shit. But for ASE, yeah, oh yeah, it's
They'll make this part of cough too.
almost. Spread them, huh? Okay. They like if you have back pockets, they make you put your pockets inside out. It's fucking crazy. Okay, so go comfortable. I would strongly recommend a good amount of rest the night before, and my rule is don't study the day before. Don't even study as you're going to go take your test. Okay, don't show up 2 hours early to sit in the parking lot and study because you're gonna forget everything you already know.
So like right now, I just can't even think about it anymore.
No, just go take it. Okay, and I'm speaking from experience. I have 18 ASCs under my name, so I take next year. I got to recertify 12. Okay, so I take them a lot and often. So this is my experience. I'm sharing with you guys what I do to take these tests. At this point, I'm taking tests on shit I don't even know. Okay. Yeah, and I passed a lot of tests on stuff I don't have no idea. I took a test on welding and I passed it. I've never welded in my life. Okay, so these are little things that I use. The only reason I'm taking all these ACs is because of my guys, Jose and Old Man and Profe. We all take ASCs together, and whoever doesn't get at least one ASC or recertify an ASC pays everybody else's test fees. So that's how we motivate each other to get pass tests. Okay, so you just gotta keep going, right? And then once you pass one, don't stop, keep going. Get Master Tech, don't stop, keep going. Okay, get Global, don't stop, go to Presidential. I'm pretty much gonna stop at Global, but yeah, you can keep going. Okay, all right, and that benefits you guys. Okay, like I told you guys when you guys sat in my class, some of you guys sat in my class, I told you I would love to have you come back, but I prefer you get your ACs. Okay, because that shows more value than you taking one of my classes. All right, and it's recognized nationally. So no matter where you go, you have an ASC. Some shop owners pay you more, some don't. If you land at a shop that doesn't care for ASCs, then you're in the wrong fucking shop. Toolboxes have wheels for a reason. They're not bolted to the ground. Okay.
Basically, when you fill them up. Once you fill the stuff up, you get them.
All right, guys. Any questions, comments, concerns?
I have a question, but it's kind of off the topic.
Go for it.
Not off the topic, but one of my buddies replaced the transmission in a Jeep Cherokee.
There's your problem. It's a Jeep. Yeah, it's a Chrysler.
I haven't got to it, but I'm gonna get to it soon.
Okay.
One of my buddies asked me for help. They said as soon as they plug in the power cable, well, they connect the battery and it starts cranking.
Oh, it's a good one.
And
What year is
I'm
it?
saying he smashed something between the dial housing or something. And
More
then
than
he
likely.
said-
Okay.
And he said the switch, the key's not in the switch or nothing. It's just, and then he unplugged the relay,
ASD?
and it was still cranking. And he said there's nothing. So
He removed the relay and it's still cranking.
But he said there's no extra wires going to no powered wires, no ground wires.
So yeah, he probably pinched the loom while he put the transmission
That's
back
what
on.
I'm thinking.
Yeah.
And I just haven't got to it, but I was like, where do I start? Because he was like, he called me and he was like, hey, I disconnected the switch, I disconnected the relay, and it's still cranking.
So
He probably smashed something between the.
I would pull the start relay, the start wiring diagram, the starting diagram, and then kind of see where everything's flowing from there. If he already removed the relay and the car's still cranking, then it's getting power from somewhere. Yeah. Which is kind of hard to believe. I'm pretty sure he took the wrong relay off
Yeah.
because that's a high current starter motor, and all the wires that go through the loom are so small they would have melted already. So he probably pulled the wrong relay. Plus, those Jeeps have the ASD, automatic shutdown relay. So if that relay's on, then this is probably still going to crank.
So if I pull the starter relay, I could trace it from there, right?
Yeah.
I could check from the starter to the relay itself.
Yeah. VD it, or if you have they sell some testing bases that go under the relay, and then it has the pins on the side.
Oh,
So then you could do a voltage drop that way. If you don't have one of those, you could do the old school way. Get yourself a small piece of wire, strip it on both ends, and then shove the relay in there so it goes into the contacts. I don't recommend this, but this is the way you could do it. And then from there, now you got an output, and then now you can go to the starter motor and then see if you have VD. If you have VD, the circuit's alive. So then now you can confirm that, yeah, he screwed some shit up. Yeah. Charge him.
Those, like sometimes they get wet, without wet or rain, what's BCMs?
Oh, I think he tried switching it already too.
Grand Cherokee?
No, it's extra.
Oh.
Regular Cherokee.
Oh.
I think he switched the computer.
But it still has that black module with 3 connectors on the passenger side. That cheap ass one. Yeah.
Like, hey, you have an extra starter? I was like, yeah. The starter. I want to do the starter. Like, it's working.
Yeah.
And then he was like, you got an extra computer? I was like, yeah, but it's not the computer. Like, full trace it back.
Yeah.
He gave up on it. He gave it back to my other. They're both my friends, but he gave it back to them. He was like, yeah, I couldn't fix it. Like,
That you handled it?
yeah, he
No.
did it to it.
No, that's gonna be something simple, especially if it happened after a transmission install. I would definitely backtrack to see what they did.
Yeah.
So I would start right there. Yeah. Because the ones I've dealt with, one of them had a bad PCM. Jose did one the other day with bad connectors, and then we had one with a bad crank sensor, but nothing like that. Yeah. I will tell you this: if you get another one that has like an intermittent stalling problem, get a little rubber mallet and then tap the PCM. If it dies, and it needs a PCM. Yeah. And then if you guys need connectors, because you know how they break the tabs and shit, we found a company that still makes them.
Oh, yeah? So
Yeah.
they replaced them?
Yeah, for the whole PCM connectors.
Yeah, because those all the clip.
Yeah, they always break. Yeah, we had Jose worked on one like that. They Jimmy rigged the shit out of it. Yeah. Any other questions, guys? I know we stayed a little bit longer than 2 hours, so I apologize for that. But hopefully you guys learned some cool stuff along the way. All right. So if you guys take your AAC, you guys come back. If you pass it, come back. I'll write you a check for your test fee. All right. So you pass it, it's a win-win because you get reimbursed for it. All right. Okay. Trick is too, if you guys are going to sign up for more than one ASE, buy them at the same time. So that way you only pay one registration fee, and then you have 90 days to take the other test. Okay, so that's what I do because I take a shitload of them and it gets fucking expensive. All right. All right, guys. So I'm all set. Thank you guys for coming. I really appreciate it. Let me know when you guys pass. And then if you guys are interested, tomorrow there is an ASE A8 review for engine performance. So you guys are welcome to come by for that one as well. That one's going to be talking about more about sensor inputs, networks, secondary ignition, primary ignition, and all that fun stuff. So we're going to be covering a lot more on that one. All right. No, do it after. Do it after. You'll have access. You'll have access to it anyway. You'll have access to it anyway. Yeah, I got you. Yep. All right, guys. Yeah, let's check it out.